Twitch stream glowing, formulas flashing, minds wide, knowledge flowing, equations on the board, numbers never sleep, teaching math and physics while them haters count sheep. Actual education, tune in and get schooled, flipping textbooks, breaking all the rules, from Newton to Einstein, concepts elevate. Keep the stream, it's the key to our fate. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice. Got the Pythagorean triangles about to flex, quantum theories on deck, breaking all the specs, relativity theories, worlds getting small, grasp the universal laws, standing tall. From the atom to the cosmos, we rolling deep, grazing up the stars, no time to sleep. Black holes and supernovas, concepts we unfold, brain power heavy, yeah, that's Dr. Gold. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice.
What is up, everybody?
That's dope.
It's Monday. That's what we got. We got the lo-fi beats going on tonight. What's going on? There we go. It's a little too like chill. Where's like some nostalgia? We'll do this. Oh, I like that. That's better. Nice. What's up, Adarsh? Good to see you. Bum bum bum. Oh, let me start us on Twitch. Let me start us off. There we go. Now we're live on Twitch. Oh, what's up, Bella? Let me share my screen. Bella, you have some good questions, that's all. There we go. We are live. Nice. Ace said he did his physics final today. It was mad easy.
That's dope.
Glad it was easy. It shows you're learning things. We love knowledge. Knowledge is great. What's up, Shantrix? The only thing I did wrong was I forgot a negative sign for my acceleration.
Oh no.
It happens. Don't worry, dude. Yeah, it's weird. Like, G is technically positive 9.8, but then the acceleration due to gravity, like A, is like negative G, so it's like negative 9. I always got confused in physics about where the negative went. In general, if you're ever doing physics things and you're confused, I just kind of like switch the signs at the end. You look at the answer and be like, should the answer be positive? And then if yes, just make it positive. My one of my advisors said this beautiful thing in weather deciding whether. So if you go into graduate school for physics, you have to decide between two different like subfields. Now there's three, but back when I did, there's only two. And you either were an experimentalist, which means you do like hands-on things like, you know, poking things and measuring things and screwdrivers and building stuff, which is what I like to do. I'm an experimentalist. I like making experiments. Or you become a theorist. And a theorist is someone who, you know, pen and paper, going through equations, trying to solve things out. And so he used to be, the professor would say, you know, if you know how to use a screwdriver, you know, go be an experimentalist. If you enjoy tracking down minus signs, like tracking down like where the negative is everywhere, then go be a theorist. And nowadays we have this new like hybrid field called a computational physicist, which blends a little bit of both, because you're running experiments, but they're virtual and they're done in like a computer, like on a simulation, but you still have to know a lot of theory to write the code to run the simulation. So that's the new field that's kind of popping up in physics. I remember we're seeing if you were a computational physicist. Yeah, computation. What's up, Sensation? Good to see you, dude.
How's it going?
How's it going? How's it going, ladies? Oh, let me put the other thing on. Here we go. Sensation, I'm YouTube is on. We love that, dude. Nice.
That's dope.
Thank you, YouTube, for fucking working for the first time. I was gonna tell you, Sensation, I'm working on my British passport.
I don't understand.
Well, my mother's a British citizen, so I'm applying for a British passport.
Okay.
You know, in case everything like goes topsy turvy here in the U.S. I don't know. Trump seems to be doing a new fucking thing every day. You know.
Yeah, I wouldn't worry about it.
Yeah, I'm not worried. I don't think, I think a lot of the media overhypes like what Trump's doing, but it is pretty extreme. Like a lot of it. Did you see this new thing with the Colombians?
It's not extreme. It's extreme from how we've seen it.
Correct.
If you even go back slightly historically before we were born, that's probably the norm.
Sure. I will agree with you 100% here, Sensation, that we've been conditioned, or I guess accustomed to a certain way of like things happening, and so there is an immediate shock, outrage of like, oh my god, like what? He did what? He said what? But it's only because we've been so coddled, I guess, for the last like 20.
Yeah, and this, it's the norm generally. Sorry, people in the West, the media especially, have no idea what in the Chinese language, which you would not get away with writing in English, not even slightly.
Sure.
Do you remember when the one, I can't remember which prince got married to Meghan Markle?
Yeah, Harry. Yeah, the redhead. The one that didn't they have pictures of him like with like naked playing like pool in like Vegas and stuff. Like he's just a fucking bachelor, dude. He's just having a fucking blast. Cause he's the spare. Mess around and find out, I guess.
He's not the firstborn, but
for the ones who get it done, the most
what?
important.
Am I getting an advertisement right now?
And the best partner
excuse me?
is the.
Someone was asking what happened about Colombia. Let's show this real quick. So, and then Bella, I see you're here. We're gonna help you out with your questions. So yeah, what I want, like, I don't want CNN or something. I just want, who's generally, Associated Press is pretty unbiased, right? Yeah, I don't know. Dude, what's this massive picture of Trump? I don't need this photo. What? Okay. Anyways, basically,
it's an old photograph as well, you'll notice.
It probably is an old photo. He looks much younger here, I guess, than he really is. But in general, just the breakdown is Trump has been going pretty hard on deportations for the last week or two, which I can kind of agree with some of them, because he's literally taking people who are criminals and being like, what are you doing in our country, and like kicking them out. So I'm like, cool, I'm fine with that, whatever. But he was using military aircraft to do so. So he was taking like military aircraft, putting on these so-called criminals that they found that are in the country illegally, and he was flying them back to Colombia. Like, they're Colombian nationals. They're Colombian citizens that got caught in the U.S., and he's shipping them back. This is ridiculously expensive, and honestly, just a fucking publicity stunt. It doesn't really probably do much. But Colombia started refusing the flights. Like, saying that U.S. military aircraft could not land and drop off these criminals. To which point...
9 minutes.
Pardon?
Said for 29 minutes.
Yeah, exactly. No, exactly. This is the whole funny thing, because like the Colombian president put up all this big stink of like, we will not accept Colombians, coming into our country in handcuffs. Like, this is unjust. It's not humane. Blah 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 blah. I don't know. And then Trump turns around and says, okay, cool, instant 25% tariff on all your fucking imports. And if you don't comply, it goes up to 50% in a week. Which I'm like, whoa. It's kind of a G move, honestly. But it's very not in the realm of what we call, like, diplomatic. It's not, as Sensation, right? We were saying this is not the norm that we've been used to for the last 20 years. Like, usually this would go through a lot of, checks and challenges and the courts, or someone would come in and whatnot. But Trump's just basically saying, like, no, fuck you, dude. 50% tariff on all your imports would, like, collapse the economy of Colombia. And so, literally, like, an hour later, yes, the Colombian president says, okay, we will accept the aircraft. And you're just like, damn, dude, wow. He also, in addition to the tariffs, he revoked all the visas of all the Colombian officials in the U.S. and then put a travel ban on any Colombian national legally coming to the U.S. So basically said, if you're from Colombia, you can't come to the U.S. even legally. So I don't know. It's just like it was an insane escalation in the course of like an hour or two, and then but it did get the job done because as you said, Sensation, 29 minutes later, the Colombian president just folded and said, "Okay, you're right. Yeah, whatever. You can land the planes." I don't know. It's fucking wild.
It's again normal for me because I saw this stuff up close and personal. In the 80s, that's how you did business.
Yeah. I mean, whatever.
And the 80s was the last time that the US was a powerful nation.
Okay. So maybe he is like, again, making America great again, or whatever you want to fucking call it, but I don't like Trump in general, but I can't deny the fact that he still gets things done, at least. Or at least he gets things done in a way that I notice it. I'm sure Biden did things, but I if you ask me what Biden did, I don't fucking know. Like, it was never communicated to me. Whereas I guess maybe Trump is a better marketer because I know everything he's doing because it gets plastered in my face every day.
He's louder.
He is louder. He's very louder. Jeff says, remember what the UK did to the Falklands in 1982? I don't. Sensation, you want to tell me what the UK... Were you part of this operation, dude?
No, that was 1982, and that's before I was born.
Okay.
The Falkland Islands War was... the Argentinians wanted the Falkland Islands back, and we said, no.
We just said no.
This has been ours since the beginning of time. No, you're not having it.
Sure.
And they tried to attack us, and then we basically parked an entire fleet of ships just out of range of their guns, and then just shot the fuck out of them. It was really quite funny because they had absolutely no chance of winning, like, ever.
Sure.
And we stopped short of invading Argentina, but we were ready
to
invade
Argentina? What the hell, dude?
Well, we would have won outright, hands down. I mean, like
they don't really have military.
Weapons could not reach us.
Yeah. But there just would have been like insane amount of casualties, I guess.
On their side. And
the Argentinian dictator thought it would be an easy win. Yeah, GG easy. Yeah, right.
We said in the SAS, and they just pacified the entire place in like days.
Yeah. Again, I don't want things to get to this, right? I believe we should all be like happy, lovey, whatever. Love your neighbor, be nice to each other and stuff. But I understand
for that.
Yeah. Sensation says choose violence.
Well, you can't just go against what makes people. People have been fighting since we could pick up rocks.
That's true. We have been.
That's not going to go anywhere anytime soon.
I agree. We
Do I think we should?
I hope
fight? No.
Yeah, I hope we would evolve to the point that we're not fighting anymore. I agree that like fighting is a natural biological process. There are scarce resources. Yeah, the reason we exist is because weaker things don't.
Yeah.
But like also there's compassion.
Apex predators were eating us, and then we picked up a stick, and we went, no more problems with apex predators.
Yeah.
And that's the only reason we're still alive.
Oh, Chandrick says the dictator did it to try to get public approval, and then he got ousted. Yeah, he fucked up, dude.
You done messed
Generally
up,
happens with dictators.
Yeah, dictators don't do fair. Okay, let me Let me get the Bella. You want to come to the stage so we can do your question?
Oh,
I saw you were
quickly, before Bella comes up.
Yeah, what's up? Yes, I need to do that. I can't do it right now because I have to. Also, I think I have to apply again to stream live on TikTok because I lapsed. Like, you have to be live on TikTok for like 3 times within 180 days. I have to like do it on my phone before they'll let me do it on my desktop. So
maybe that's why I'm having problems.
Yeah, you can't do desktop TikTok streaming until you get approved for it. Like they don't let just anyone stream on desktop live for TikTok.
TikTok won't let me use it for shit, like nothing at all. I can't follow you. I think.
Oh, really?
I messed up one of your things.
Were you starting too many fights? You starting too many fights on TikTok, dog?
I literally only just signed up to it like the other day, so.
Oh, okay.
Nothing.
They know about your SAS status, dude. That's what it is, dude.
Yeah.
Surprise, motherfucker.
Not a spy.
Okay. Not a spy. All right, here. Let's do Bella's question. Start off the stream, and let's get you guys some help. All right. Welcome, everyone. Office Hours. My name is Dr. Goldsack, Education. Stream that helps you with math, homework, science, homework.
Nice.
All sorts of fun stuff. Here, one sec. Let me turn this lo-fi music is too loud for me. Okay, cool. Awesome. All right. What's up, Bella? How's it going?
Banging techno.
I do want some banging techno, dude. Let's do it. Do the banging techno.
Sorry, Bella, questions. Yes. Sorry.
Bella, questions. What's up, Bella? Does your mic work? She's a speaker, but I can't hear.
Yeah, when you shut up.
She's like, sold off. I see her in the thing, but I don't see the green on her thing. Maybe chat to us, Bella. Here, I'm gonna chat to her. I'm gonna chat. Bella, can you hear us? Hello there. Dude, I got so many awesome green screens I want to use for. Oh, she left and now she's coming back. Maybe. Okay, let's try this. Let's invite Bella back in. 1 sec. Let me do this. Yeah, I remember there's like some issue with like yes, let me invite you to speak. Cool. There we go. Yeah. Test.
Hello?
Yeah, she's here.
That's dope.
Nice, good. You made it.
I was saying I go live on TikTok.
You do? You do it with your phone
Yeah.
though, right? You don't do it from a desktop.
No,
yet.
I do it on my computer.
Oh, you do?
Like I stream games.
Oh, that's dope. Did you have to apply for something?
No.
No. Okay.
Like
Maybe.
I downloaded TikTok Live Studio on my phone and it said I qualified or whatever,
Oh,
but I didn't
okay.
like touch or I didn't like
You didn't like do shit. You're
any
just like,
application.
you're just
Yeah.
like, I'm good. Okay. maybe I'll try that again then.
So I think you download TikTok Live Studio on your computer and then try it.
Do you get a lot of people in your TikTok lives?
Some days, yeah.
Yeah, some days. I was talking to another education streamer. Her name's Rocket Sage. Here, I'll give her a little shout out at some point. There's a YouTube Shorts live now. Oh, that's cool, Shantrix. But she was telling me that the issue she has with TikTok for live is that it tends to be like a rotating door. Like people just come in, they say hi, and then they just leave. And so it works if you're just some like cute person with like, hey, send me gifts and just say hello. But in terms of actually engaging with the audience, it doesn't, I guess, really happen all the time or something.
I see this guy. He does like cooking streams and he gets like
Cooking streams. Okay.
1K.
Okay.
Yeah.
And
then they stay for a long time. So.
Okay, then maybe we will do that. Yeah. My whole issue I had with running this stream on TikTok was that the format. So this is obviously like a widescreen thing, but TikTok is vertical, and so it's hard for me to like.
It has like a dual layout. Like you can choose whether you want like vertical and landscape.
Oh, okay. Okay, maybe I'll try that. Yeah, if people just rotated their phone, then it would look okay. Because I know people that are watching me right now on Twitch on their phones. You're probably rotating your phone because this is the format that Twitch streams are.
I thought that was mandatory. I thought you had to turn your phone.
No, you don't have to. Yeah, dude, they did all this new stuff with the Twitch update. I'm not really sure I like it, but whatever. They're trying to make it more like TikTok.
I think it forces you to if you press the button like full screen.
Oh, if you do, it forces. Okay, if you full screen it. Okay, that makes sense then. Yeah. Okay, cool. All right, you got physics coming up, yeah? You got a test coming up? What's crack-a-lackin'?
I just finished midterms, and now I'm starting this unit.
This unit. Yes.
I don't
okay.
know. I didn't understand anything.
Okay, it's all right. We're here to make things make sense. Yeah. Oh, I love how. Do you know why, for instance, they have this 1 and then this 2 by the questions?
Yeah. Is it like difficulty?
Good. Yeah. This is a level 1 question, then this is like a level 2 question.
Yeah.
So yeah.
I can't solve a level 1. It's kind of.
It's okay. You can't solve a level 1 yet. What's up, Recky? Good to see you. All right. All right. So here we go. A jet plane is traveling at. I love how they put the meters per second because this is so annoying when they put this in the question like miles per hour or like kilometers per hour. Like this is useless. You always need the meters per second to actually do the question, right? Okay. Pulls out of a dive by moving in an arc of radius 6 kilometers. What is the plane's acceleration in G's? Ooh. Okay, cool. I like that. All right. So let's imagine our plane. I'm gonna try and draw a plane. Maybe it's like well, this is kind of like a bird, but like whatever. All right. There's my plane. Okay. And it's going into a dive this way, right? And then they say it's like pulling up, so it's gonna do some sort of thing like this, right? To try to avoid hitting the ground. Okay. that motion that it does is technically a circular motion. Okay.
Right.
It doesn't go for the whole circle, right? But as it goes from like here to here to pull out of the dive and prevent itself from like anti-heroing, it is doing circular motion.
Right.
Right? Okay, cool. All right, so this is what we're going to call the radius, all right? And this radius of the motion, right, stays the same like this. As the plane goes from like here to here, right?
Yeah.
Okay. Whenever something moves in a circle, it experiences what's called centripetal acceleration, which we're going to say is A sub c, okay?
Okay.
And that is always equal to v squared over r.
Yeah.
Okay? All right.
I have that and then another one.
Good. You probably have this one, mv squared over r, which they say is like the centrifugal force or something. Or centripetal force.
Or we're using like the area of a circle and the circumference to like
area
fill
of circle?
in.
What?
Or like I don't know. Like
oh, I think what you I think you have
pi
this.
r.
I think you have like the area of something traveled, like the arc is equal to something.
Yeah.
Yeah, we'll get to that. We'll see if that comes up. I don't know, but yeah.
Like,
Okay.
can
So
I give you,
what's up?
Can
You want to
give
give me a
like, an
screenshot of it?
example of what we did in chat or in class?
Yeah, sure. Yeah. Give me whatever.
Okay.
Bum, bum, bum. This is like one of the hardest concepts in physics, in mechanics at least, to understand centripetal acceleration. It tends to
It's, like,
mess with people's minds a lot.
I Okay, I sent it. Or
Alright,
where should I
nice.
send it?
You can send it in chat, or you can send it help screenshots, wherever you want to send it. It's cool.
Okay.
Just tell me where you send it.
I sent office hours.
Oh, office hours. Okay, the OG chat. Okay, cool. All right. Let me pull this in. Velocity is always tangent to the circle. Yeah, no shit. But what? What is your teacher? We're gonna do some deep diving into your teacher's questionable teaching. Okay. C equals 2 pi r. A equals pi r squared. Why don't? Yeah, duh. Yeah, I know that for a circle, but why does that apply here? Okay.
Like
I see what they're doing. So they say centripetal acceleration, a sub r, right, is v squared over r.
Mm-hmm.
And v, velocity, okay, is equal to distance divided by time, okay?
Yeah.
Now, the distance something travels when it moves in a circular motion, that's the same thing as the circumference.
Okay.
Okay?
Oh, okay. That's why they... Okay.
So here what they have here. So this is revolutions per second. This is like an omega, right?
Mm-hmm.
Omega is what's called like angular frequency. It's like how many oscillations you do in a certain period of time.
Yeah.
And they're multiplying that by the distance in one revolution, right? You see how 2 revolutions in 1 second, and then 1 revolution is this distance. So now you get a distance over a time, and this is now the velocity. Yeah.
Yeah.
A equals pi r squared is not needed anywhere. Yeah, we don't need that. It's useless.
Okay.
Okay. Yeah. They're just doing this to figure out the velocity. If instead of telling you the velocity, they just tell you how many revolutions it does in a certain amount of time, you can determine the velocity that way. Does that make sense?
Okay.
Yeah. Yeah. Okay, cool. All right. So for this question though, okay, we have a plane. It's diving down, and it pulls up because it's trying not to die. And when it does that, it moves in a circular motion. And anything that moves in a circular motion has an acceleration called centripetal acceleration, which is equal to v squared over r. Okay?
Yeah.
The reason why this is, yo, what's up, your average gamer? 2008? Oh, cool. I remember 2008. That's when I graduated high school. Okay, let's remember, what is acceleration in physics? Like, it's changing something, right?
Like the formula?
No, just what I mean. What do you think acceleration is? Like, how would if someone came up to you and said, "Yo, Bella, what is this acceleration thing?" What would you describe it as?
Oh, I don't know if I'm right. Like,
that's okay.
How it speeds up.
How it speeds up. Okay, cool. Yeah, the formal definition for acceleration is it's the change in velocity.
Oh.
Have you heard this before, right? Acceleration is change in velocity. Yeah, okay. In fancy math language, they write this. They say dv/dt.
Oh.
Which
yeah, that's
is,
what I meant, like the formula, like change in velocity over change in time.
Good. It's change in velocity over change in time. Excellent. Okay. Nice. Anyways,
people annoy me.
Yeah, whatever. Yeah.
What?
Yeah, what
type?
What type of video did you put in the chat? Yeah, it's okay. Yeah, you deal with them. Thanks, Sensation. Okay, so, all right. So here's the cool thing about change in velocity. Let's remember, velocity has two components to it, right? Like, what does velocity have? It has a magnitude and what else?
Direction.
Good. Direction. Has a direction. Yeah. Okay. So, even if let's say, for instance, something is moving around in a circle at a constant speed. Okay, let's say it's moving just at 30 miles an hour and it's just going around in a circle. Some people would think that the velocity is not changing, right? Because it's going at the same speed, right? Speed's not changing.
Right.
The difference is that in order to move in a circle, your direction does change, right? Here, you're moving down. Here, you're moving to the right. Here, you're moving up. Here, you're moving to the left. What's up, High Potential? Dr. Gold will finally settle which hand we're meant to use the right hand rule with. The eternal question, dude. What's up, dude? Yeah. What's up, High Potential? He's another cool. He runs even longer office hours than I do. High Potential streams, I think, for like days at a time. He just never turns off his Twitch. But he also calls it office hours, which is cool. Okay, thank you, dude. Yay! What's up, Rocket? Good to see you. I enjoyed your stream today, Rocket. That was fun. I was at the gym. I just got notification.
Oh, I shouted out your YouTube channel to my teacher.
Oh, no way.
That's dope.
Everybody's like, oh, let me know if you guys have any like videos on YouTube that you find easier to understand or whatever.
Ooh,
and I was
okay.
like, oh, will you give me your the pulley?
The pulley video I did on TikTok?
Yeah.
Which one was that?
And I was like, oh, well.
Yeah, this guy's kind of cool. He's got some videos. Oh, it was the Forces one. What was it?
Yeah,
I did.
the Forces. And then I told him that you had like a whole physics playlist on YouTube.
I do. Yeah. Oh, is this one? This one with the pulleys?
Yeah.
Yeah, this is a fun video. I remember this one. But yeah, no, I'm glad. Yeah. Tell more of your teachers that I have these videos. I mean, they're free, you know. And if they're useful and you learn from them, other people can learn, right? Yeah. Okay, so back to your question though, right? So if we have the plane, right? And even if it's moving at a constant speed in a circle, because the direction is changing, that's why there's an acceleration, because velocity as a whole is changing. Yeah. Okay. So what I like to always do is to figure out when the plane is at, or when anything is at a certain point in the motion, what are all the forces acting on it? Okay. And let's see here. They say like pulls out of a dive. Okay, what's the plane's accelerations in G's? Okay. I assume they're talking about where is the maximum acceleration, right? Or actually, no. The acceleration is the same. I take that back. The acceleration is the same, but the force that you feel will change. It's actually pretty cool. I'll show you where it comes from. So let's say that you are the plane and you are at the bottom here, okay? Of the dive. What forces are acting on you here? Like, what do we feel? Gravity? Yes. Say it loud, Bella. You can say it loud. It's good.
No, I don't know anything else.
No, yeah, exactly. Well, great. Yeah, it's just gravity, right? This is the force of gravity,
okay.
Right? Cool. And then if you were a plane, right? The only other thing that can provide force, right, is the thrust of the engines. Is what we would say. If you were a person, let's say you were a person, like just sitting on the plane, okay? You're just chilling on the plane. You feel the force of gravity pushing down, and then you would also feel the normal force of the bottom of the plane on you, okay? This normal force is also how heavy you feel. Have you done that before? The elevator question? Did you do that before?
Yeah.
Yeah, right? Yeah. If you have like an elevator and just person's just chilling, like if the elevator is accelerating up or like accelerating down or something, how heavy you feel changes. Yeah. And that's because of normal force. Yeah. But regardless, at any point along this circular motion, because I'm moving at a certain speed or this, they say this is like the magnitude of velocity, and there's a radius, you're always going to feel this acceleration. And that's called the centripetal acceleration. So, you just plug in the numbers here. So AC is equal to 525, let's say squared, over the radius. And the radius they refer to is the radius of the curve, or whatever the circular motion is, which is 6 kilometers, yeah. But what do you got to do with this 6 kilometers? You got to be kind of tricky with it.
Meters.
Meters. Yes. How do I write 6 kilometers as meters?
6. Is it 600 or 6,000?
It's 6,000.
Yeah.
Yes, 6,000. 6,000. Yeah. That's another big thing, Bella. It's always we're always like trying to build your confidence up. Yeah. Just say you're smart, Bella. Like you know how to do this stuff. You know, you just gotta say it. Okay, cool. So yeah, that's literally what it is. It's just v squared over r. It'll get harder.
In class, it was like, oh, there's like the 2 parts, because
yeah,
from the page I showed you, the page I showed you,
yeah,
he was like doing all that random stuff, and then he's like, oh, you have to do that for the second question. I was like, oh, well, I don't know how to do that.
Yeah, this was him. He does this thing to figure out the velocity, doing distance over time, and then he figures out probably the acceleration from just doing v squared over r. Yeah. So one part of the question here, this first part, or this right here, was to figure out the velocity, and then he just plugged that in to get v squared over r. But also, where did this 1023 come from? Like what?
I think it was.
It's another question,
below,
I think, right?
Yes, below it. Below that equation.
Yeah. This doesn't match up with this. It's okay though. This one, all you have to do is you just take your calculator here and just plug this in, right?
Yeah, I got 45.94.
Okay, let's see. So I do 525 squared divided by 6,000. And oh wait, no, divided by, not just equals 6,000. Okay, divided by 6,000. Good, yeah, 45.94.
Yeah.
Nice. Yep, 44. That's a huge acceleration, by the way.
Oh.
Yeah, 45 point, was it? Yeah, 94 meters per second squared.
Yeah.
It's actually kind of fun. So, what's the acceleration just due to gravity? Like, what does gravity feel like?
9.8.
9.8, right? Yeah. So this right here is almost 5 times the same feeling of gravity.
So if I were like 5 times fatter or something.
Yeah, you would feel. Yeah, I think it's actually technically 4 times because we have to. It's like times 5, but it's like plus 4, right? It's one of those things.
Oh.
It's like a 400% increase, but it's a 500x or something. Yeah. But yeah, you would feel really fat basically. Yeah. And this would change at the top. At the top, you would feel really light. We'll see. That'll probably be the next question. But yeah, that's the first one. Does that make sense? Yeah.
Yeah.
Nice. What was the next one?
3.
Okay, 3. Calculate the centripetal acceleration of the Earth in its orbit around the Sun and the net force exerted on Earth. What exerts this force on Earth? Oh, this is fun. Okay. Assume that Earth's orbit is a circle of radiuses. Hint, see the tables. Yeah, because they want us to look up a bunch of numbers for this. It's kind of annoying. But we can just ask Google for it. Or ChatGPT. Or maybe we should ask this new Chinese ChatGPT they came out with. Anyone hear about this today?
Yep.
Right? Yeah.
Before everyone else did.
Yeah.
What is it called?
Yeah, what is it called? Sensation. What's this ChatGPT thing called?
Oh, shit.
Is it called like?
Sorry, this was months ago, weeks.
No, this happened like today though. They made an announcement where they said our AI engine is like 1/10 the cost of ChatGPT and like 3 times better, and then all of the AI stocks in the U.S. just had a really bad time today.
DeepSeek.
DeepSeek. Thanks, Jeff. Yeah, and thanks Sensation. Yeah, DeepSeek.
And have you heard the jokes?
What are the jokes? Tell me the jokes.
So you can't ask it any
about Mao Zedong.
You can't ask it certain questions at all.
Like you can't ask about Tiananmen Square. Just be like,
who is the leader of China? I'm sorry, I can't answer that question.
Who is Winnie the Pooh? Are you allowed to ask who the Winnie the Pooh is?
What happened on the 4th of July 1989? I'm sorry, I can't answer that question.
I'm sorry, Hal. Or was it? Well, Hal's the robot. What does he say? I'm sorry,
Dave.
Dave. I'm sorry, Dave. I can't do that.
Open the doors, Hal.
Open the doors, Hal. I can't do that, Dave. Yeah, that's it. Yeah. This movie goes over the heads of most of our audience, but it's okay.
Everybody should watch 2001: A Space Odyssey. It might be old, but it's like a really good movie.
That's a classic. Okay, let's see. I drew the sun here. Let's draw like a little happy sun, right? Well, sun should be looking at us, right? Yeah, look at that. What's that? Okay, there's the sun. Here is us on Earth. And they want to know the centrifugal acceleration of the Earth in its orbit around the sun, right? Because, and this is kind of, physics does this. We start approximating things because it turns out the rotation of the Earth around the sun is not a perfect circle. No. It's actually an ellipse. Yes, Shantrix. I'm glad you get them. Yeah, Shantrix is a purveyor of fine memes. Or old memes, I guess. So we're going to assume that the orbit is circular. In reality, if I talk to any of these astronomy streamers, they would say that it's actually like this. It looks like an egg. Yeah. I forget why this is. If anyone in the chat wants to tell me why, but it is. But for the sake of this question, we're going to assume it's circular. What's up?
Sorry, what's egg?
Why the orbit of the Earth around the sun is an ellipse and not a circle?
Because of the pushing and pulling factors.
Yeah, but why do they change?
As you approach a heavier object, you move faster. And so it wants to throw you out of orbit. And so when it pulls you back in again, it makes an ellipsis.
Man, sounds like the sun can't make its mind up. Just when they think I'm out, they reel me back in, dude. Okay. All right. So, Earth is moving around, and it has some radius here, right? Which we're going to call 1.5 times 10 to the 11 meters, okay? And they want to calculate the centripetal acceleration. Awesome. Okay, so this is cool. So centripetal acceleration, right? We remember is v squared over r. Yeah, Jeff is right. Yeah. This is called the two-body problem, technically. There's a lot of simplifications happening in this because it's a high school physics question. Technically, they do kind of revolve around each other, and there's like this kind of like drift and thing. Yeah, but we're not going to go over that. Okay, so we know what the radius is, right, Bella? Mm-hmm. That's just the 1.5 times 10 to the 11.
Yeah.
How do you think we figure out the velocity? How did we? Your teacher did it. Your teacher did it here.
Like when you plugged in, or he plugged in.
This thing. Distance over the time.
Oh.
Right?
Yeah.
Yeah. So watch. So V, right, is equal to the distance divided by the time. All right. What distance does the Earth travel as it goes around in a circle? There's a name for this in a circle. What is this called on a circle?
Wait, what?
Starts with a C. What's the distance around the circumference?
Oh.
Yes. The distance Earth travels as it goes around the sun is the circumference of that orbit, right?
Oh.
Yeah. Okay, so that's 2 times pi times the radius. Okay?
Yeah.
which I'm gonna leave this. I'm not gonna calculate the math yet, and I'll show you why. Okay, 2 pi. All right. Okay, 2 pi r. Right. That's the circumference, and then the time. What's the amount of time it takes for the Earth to go around the sun?
Wait.
No cheating.
I know, this is a great question.
Like 365.
Yes. Okay, so there's some nuances to this. So, yes, you're correct that there are 365 days in a year, and we think that 1 year is the amount of time it takes for the Earth to go around the sun. Technically, it takes 365.25 days to go around the sun. Did you know that?
No.
No, okay. So the 365.25, do you see how like there's this extra quarter of a day that kind of hangs off? Where do you think that extra quarter of a day comes into our daily life or things? Like, how do we deal with this? How do we deal with that? Technically, there's a quarter of a day missing every year. Daylight savings? Oh, that's an interesting idea. Yeah, maybe. Daylight savings sucks, I don't like daylight savings. Not a fan of daylight savings. Frogs.
It's a good hint.
Frogs is a good hint? You're saying
Think
frogs
about
is a good... Think about... Oh, I do like that. That is a good hint. Okay. I mean, it's kind of a deep cut if they don't know it. Okay. What happens every 4 years?
What happens every 4 years?
Yeah, what happens every 4 years besides the Olympics?
How many days are in February?
How many? Oh, good. How many days are in February? That's an even better one.
I don't know, guys.
Okay. It's called a leap year. Trump gets elected. Oh man, Jeff with the savage comments today. Yeah, no. Every 4 years is a leap year, right? What do you remember what's special about a leap year?
I don't know.
You get an extra day in February.
Oh, okay.
So instead, February usually has 28 days, but on a leap year it has 29. So that's What's up, Dennis?
Oh, so then it makes I get it.
So every 4 years, that quarter of a year that we're rounding off and like just chopping comes back as February 29th. Yes.
Yeah. Okay.
Yeah. Dennis loves this stuff. Dennis is a big astronomy guy. So yeah, we're doing a little bit of astronomy.
Yeah, I actually didn't know what a leap year was.
Oh, good. Well, I'm glad you learned something today. Wow, pencil breath. Thanks, bro. Love the donations.
Why? Why are you eating pencils?
Pencil Breath just donated $5.
Yeah, why are you eating pencils? Do you want to elaborate on your username for us, please? Oh. Okay, great. Yeah, so the time here, right? Yeah, we're going to say is 365.25 days. This is how you can like show off to you can flex on your physics teacher. Be like, yo, it's actually 365.25 days.
I don't know what he had on or what it has on the workbook page, but like he told us to take a picture and I was like too lazy to go over there.
Oh my god. Kevin Saw says
not everyone took it, so.
Yeah. What's this? Oh, in the chat. One sec. Kevin says, want to say I got 100% on my exam. Thank you for the help, and it helped me out. Yeah, cool. Dope, Kevin. You're welcome, dude. Hell yeah. All right. Your teacher had a table, you said, that you had to take a picture of?
Yeah.
Yeah.
I mean, it's in the book somewhere. I just don't know.
Yeah. Yeah, okay, so this is cool, because this is in meters. The issue here, right, what does the time need to be in if we're dealing with physics stuff and velocity?
Like meters per second?
Meters per second, yeah. Yeah, exactly. So technically, I want to convert days here into seconds. That has to happen first. Do you know how to do that?
Like times, or 1 day. Wait, I need to like write it out.
Yeah. So here, I'm gonna. There's an easy conversion, and I'll just tell you. It's a good number to know. It'll just help you out. 1 day is 86,400 seconds.
Oh.
Yeah. There's all these like motivational things you see on Instagram and stuff where they're like, what if someone gave you $86,400 every day? What would you do with it? And it's like, that's what happens every time you wake up. You have 86,400 seconds to make a difference. Excuse me? I'm not fucking doing something every second. What? It takes me like 5 minutes to like cook breakfast. Like what? Anyways, so yeah, this is a cool number to know. You should know this one.
Okay.
Yeah. Because then you don't have to do the days to hours, hours to minutes, minutes to seconds. You know, they're just.
I usually just do like until where I need to get like 3600 or whatever.
Oh yeah, 3600 seconds are in an hour. Yeah.
Yeah.
Yeah. Yeah. So the next evolution of that is just to know that it's 86,400 seconds in a day. Okay. So we can get a number for that. So if we pull up the calculator, right? 365.25 times 86,400. This is a really big number, but whatever. You know, I can actually put this in scientific mode, so I just don't have to deal with that. Or it's called engineering mode, I think, technically. Yeah. There we go. 315.58 times 10 to the 6. Okay, cool. Wait, that's actually weird. Shouldn't it put it in what? I want it in
like
one decimal.
3.2.
Yeah, I want that. Like what? The engineers like, okay, that's better. Oh, that's weird. Okay, whatever. 3.16 times 10 to the 8. That's what I want. Why does engineering mode have more numbers after to the left of the decimal? That's wrong. 3.16 times 10 to the 8th seconds. Oh, engineering powers must be multiples of 3. Oh, thanks, Jeff. I didn't know that. See, I learned things too on these streams. Why? I don't know. Probably because of like kilometer and like megameter and it like giga, tera, whatever. They're all like powers of 3. Oh, yeah. Engineers are dumb. Yeah, that's true too. Okay. Anyways, all right. So this will give us a velocity. Okay. Which we can then plug into here. Okay. So now we're gonna get 2 pi times 1.5 times 10 to the 11th. And we're going to do that all squared. No. This was us just getting the time, right? Okay, here, one sec. I gotta do this like step by step for you guys. I don't want to multiply all the numbers yet together because I want to show you that things cancel.
Oh, okay.
Yeah, watch what happens. Okay, 3.16 times 10 to the 8th seconds. Okay, this is the velocity, right?
Okay.
And then we're going to do that squared. So here, I'm going to copy paste this. So I'm going to say it's this squared over the radius, which is 1.5 times 10 to the 11th. Okay? Mm-hmm. The cool thing here is, do you see how this shows up here and it also shows up here?
Yeah.
Yeah. So when this thing gets squared, one of these will cancel out this one, which is kind of nice.
Oh.
Because V, let's remember V was equal to 2 pi r over t. And then if we do that squared over the radius, right? Then you have an r squared over r. So it kind of helps out sometimes. But all right, you can just put this in the calculator. Let's see what we got. So we get 2 pi. Oh, did I mess up? Yeah, no, you're supposed to multiply by 86,400. Oh, I put an extra 0 on it. Oh, thank you. Okay, cool. Thanks, Jeff. Yeah, I made a calculator mistake. Yeah, this should be times 10 to the 7th.
Okay.
It's okay. Life happens sometimes. Yeah, save the day. Yeah, Jeff, you get a save, dude. Thank you, man. Appreciate it. Yeah, I would have gotten something wrong, dude. I think put $ saves at Jeff. Does that work? Okay. See if you can do it. You can give him another save, Jeff. Sensation. Yeah, what's up?
So is it still 86,400?
It is. Yeah, no, it is still 86,400. What they're talking about is like in the calculator, I put an extra 0 when I type that number in.
Okay.
Yeah. Oh, you can. Nice. Good. Okay, cool. All right. Sensation can give the saves out. Okay. So I'm just going to take this and divide it by 10. Okay, cool. All right. So 2 pi times... Actually, I think that means, Jeff, you can give yourself saves, because I think you just need to be a mod. But don't abuse that. Okay, so it's this. Good. divided by, all right, I'm going to square that. Yeah, and then I'm just going to divide by one of the 1.5s. But, again, this is just calculator. You just plug this in your calculator. Cool. All right, that gives a big number. So that's 5.92 meters per second squared. Times 10 to the 12th, sorry.
Okay.
Yeah. Okay?
Yeah.
All right. Now, they say, what exerts this force on Earth? Okay. So, in order for something to have an acceleration that's pointing in this direction, do you remember like F equals ma, right?
Yeah.
Right. So, anytime there's an acceleration, it means there has to be a force. A lot of times when things are moving in circular motions, maybe it's attached to a rope. You know, maybe the sun has a giant rope that it just throws out to us and then just pulls us in. So that would be like the tension in a rope. That's usually something. It could also be, in the case of like a car going around, it's the friction between the tires and the road that keeps it moving in a circle. In the case of space stuff, it's the force of gravity.
Okay.
Okay. So gravity between these two objects is what provides a force that pulls us in. Yeah.
Okay.
Cool. Okay. And the net force exerted on the Earth. Okay. So if we look at the Earth, right? I know we always say, like, right, the force of gravity is always happening, but this is like in like outer space. So now the force of gravity doesn't point down. It points towards the bigger object, which in this case is this. So that force, which is equal to m times AC, which we just found, right? All we have to do is then multiply this centripetal acceleration we got and times the mass of the Earth.
What's the mass of the Earth?
Good question. That's probably in the table that you needed. Mass of Earth. 5.97 times 10 to the 24th. Okay.
Oh.
Yeah. So here, we'll put that in. 5.97 times 10 to the 24th times 5.92 times 10 to the 12th. Oh, this is just super large. I mean, it is the Earth and the Sun, so. 5.97 e to the 24th. Okay, cool. And that's going to be, 3.5 times 10 to the 37 newtons. Whoa. That's big. That's a lot. 10 to the 37 newtons. Okay, cool.
Okay.
And I think that's it. Yeah, that's all you have to do. I'll send you all the pages for this too. I'll send you the PDFs, so don't worry about copying everything down.
Oh, okay.
I mean, if you want to, you can, but I'll send you all the pages for this. Okay, cool. What was the other ones? I like this. I like doing physics. 5 and 6? Okay, let's see. And then we'll go do all the math fun stuff that I know Shantrix and Ayush and Adarsh and Ace post. I love the math challenge questions. This is like my element. I don't feel like many people stream physics help. Kind of the unique thing about me, besides all the other things about me. Okay, here we go. Suppose the space shuttle is in orbit 400 kilometers from the Earth's surface and circles the Earth about once every 90 minutes. Oh, there are so many tricky things here. I see why this is a level 2 question. It's about to hurt. Okay. Okay, I gotta draw some pictures. It is a level up. Yeah, it's leveling up for sure. Okay, here's the Earth, and we have the space shuttle, which is going to be located 400 kilometers from Earth's surface. Okay, so we're gonna say from here to here is so 400. I want to convert that to meters eventually. So that's times 1,000. So that's 4 times 10 to the 2 times 10 to the 3. So that's 4 times 10 to the 5. I just like to convert everything to meters just straight off the bat. It just helps out.
Okay.
Do you understand how I'm doing that? It's okay if any of these steps don't make sense. Yeah, just let me know. Yeah, okay, cool. All right. So 4 times 10 to the 5. Okay, cool. According to AI, your last answer is orders of magnitude off. Oh, really? Okay. Maybe I screwed up. We'll go back. I'll look at it in a second. Yeah. I'm pretty sure I did it right. 2 pi r over... One sec. Let me make sure that's right. I want to make sure that's right. Seconds in a year. Sorry. Yeah, 3.15 times 10 to the 7th. I just want to make sure this is... Wait, what was wrong? My force or my acceleration, Jeff? Okay, one sec. All right, he's gonna go look at it. All right. See if you can find the bug for me, Jeff. I'll give you another save if you can figure out where I messed up. The physics is right, but there's probably some number that's just wrong on my calculator. Okay. It circles the Earth once every 90 minutes. Okay. So this is 1 revolution per 90 minutes. Okay. Which, again, we're going to do that just in seconds. So we're going to say 90 times 60. So that's 1 revolution. Or I'm just going to put like what the delta t is. So delta t. Did I divide by the square of the radius of the orbit when dividing? I think I did. Did I not? No, I just divided by just the radius because it's 2 pi r. 2 pi r squared over t divided by r. And so one of the r's cancels out. Actually, you don't even need to divide by r, I think. You just have to divide by t. Actually, Jeff's right. One sec. I did probably mess this up. One sec. 2 pi r over t over r. This is squared. Oh, so I don't need to divide it at all, actually. Sorry, my bad. Sorry. One sec. Let me get these numbers right. I just... math. Or it's not math. This is calculator. Okay. It's 2 pi... that, right? And we're going to square that. And then I'm going to multiply it by just one of these. Yeah, okay. Yeah, okay. And then I'm going to divide it by 3.16 e to the 7th squared. Yeah, that was it. Oh, is it really? Is it times 10 to the minus 3 then? Is that really the acceleration? I feel like the acceleration should be big. 2 pi r over t. Jeff, tell me if this is right. Because this becomes times 10 to the minus 3. Oh, it should be small. Oh, okay. Cool. All right. All right, so yeah, I was wrong with this. Otherwise, we'd float towards the sun. Yeah, that would be bad. There's a movie about that. W, Jeff. Yeah, thanks, Jeff. Yeah, thanks for catching that. Yeah. So, yeah, the math is correct. This is fine. I just put it in my calculator wrong. Again. It's Monday. So now the force goes down by a factor of... You're right. Well, I forget what I had it before. What did I have before? 3.5?
It was 37.
Oh, it was 10 to the 37? Okay.
Yeah.
And so that went from... That went down... Oh, okay. 37. So it's 15 orders of magnitude down. So 22. Okay. Okay, there you go. Problem solved. Yep. I agree. Okay, cool. Still big. Okay, so delta t here is then going to be 9 times 6 is 54, and then you have 2 zeros, so that's 5,400 seconds. Okay?
Okay.
Find the centripetal acceleration of the space shuttle in orbit, expressed in terms of g at the Earth's surface. Say in terms of this. Okay. So, where this is getting tricky is students would be tempted when we write out that AC equals v squared over r, they'd be tempted to use this as the radius. they would say that it's the 400 kilometers from Earth's surface. In reality, the radius is from the top to the Earth's surface plus to the center of the Earth. Okay. This is this whole distance here is the radius.
Okay.
Yeah, this right here is what we call R. Okay. Because R is always the radius of curvature. Radius of curvature refers to, if you go around in a circle, what's the distance from the edge of the circle to the center of the circle.
Right.
Okay.
Right.
So it's not just this part here. But the Earth isn't a perfect sphere, correct? Again, spherical cowl, whatever. Have you heard the spherical cowl thing before, Bella? No. So again, this is kind of a theme of these questions, is that in physics we make approximations of things so that the math is easier. Because if we were to take into account like all the little real world differences, it makes it really hard to get exact numbers, and it doesn't really matter. Yes. So Jeff said assume a spherical cow. So there's a joke in the physics community that whenever they're trying to figure out things like forces on objects and like gravity and whatnot, they say, okay, we'll just assume the cow is a fucking ball. Because if it's a sphere, it's a lot easier to deal with. Like if we tried to describe the cow in the actual shape that it is, it becomes really tricky to try to like solve for things. But if we just say it's a ball, then like it's a lot easier. Moo. Be a goof. Yeah. Okay. Okay, so we need the radius of the Earth. That's the other thing we need. Okay. And I'm just gonna get it in meters. Okay. 6.38 million meters. Okay. So this number, right? So this is obviously not to scale. This is 6.38 times 10 to the 6th meters. 6.38 times 10 to the 6th. Okay.
Yeah.
Okay. So now when we do our calculation, right? So v squared. So remember that's 2 pi r over t squared over r, which is going to equal to 4 pi squared r over t, because one of these r's will cancel with this one. Right? Like if I were to fully multiply this out, right? I'm sorry, there's a squared here as well. This would be 4 pi squared r squared over t squared, and then over r. But one of these r's will cancel out the t squared here. So it's just a single r. So now you can just plug numbers in. Does that make sense?
Wait, I'm still stuck on like the 4 pi squared.
Good. Okay, here. Let's multiply this out, right?
Oh, you squared it. Okay.
Yeah. Do you see how that's 4 pi squared r squared over t squared? Yeah. But then we divide it by r.
Yeah.
For this r, right? This r is going to cancel out this one right here.
Oh, okay.
And that's why we just write it like this, yeah. I'm just writing it this way so that when I put it in my calculator, I don't make a mistake and Jeff like gets mad at me. Okay. 4 pi squared. And now the radius is going to be the sum of these two things. Okay. So that's 6.38 times 10 to the 6th plus 4 times 10 to the 5th. Okay. And then that's divided by t squared. Okay. Which t we said was 5,400 seconds, right? So that's 5,400 squared. Okay?
Yeah.
Oh, wait. They say express your answer in terms of g. Okay, whatever. We'll get it later. Okay. I'll show you how we do that.
I thought it was... Oh, actually, never mind. Okay.
Yeah. Okay, so if we put this into the calculator, we get 4 pi squared. And then we have to do 6.38 e to the 6 plus 4 e to the 5th. Yeah, it's a dollar sign. Yeah, there you go. Oh, what's up, Penn Center? Good to see you, bro. Good. Okay. And then we're going to divide that by 50. Yeah, it's the dollar sign because it's Enigma's bot instead of exclamation point is not bot. Yeah. Okay, there we go. Cool. Oh wow, that's a really nice number. Is that real? Is that real? Yeah, it's actually really nice. 4 pi squared. Now I'm doubting myself all the time with my math or my calculator input. But yeah, I think that's right. Yeah. Okay. Cool. So that's 9.118. Okay. So we get the AC is equal to 9.18. Okay. Okay. So, if we want to express this in terms of G, right? Remember that G is equal to 9.81, right? So if you do this over this, so watch this. If I do like AC over G, which is equal to 9.18 over 9.81. So this is our centripetal acceleration. This is the acceleration due to gravity. This is ours. This is due to gravity. This gets us and here I can put this out. We don't need scientific mode anymore. This is annoying. 0.94. Okay.
Okay.
And then if you move this G over, like cross multiply, like put it over.
Yeah.
That means the centripetal acceleration is 0.94 of a G, of a regular G. So it's slightly less than the acceleration due to gravity.
Okay.
Yeah. And Shandrick says, yes, this makes sense because as you get farther from Earth, you should have less gravitational pull, right? Do you understand? Well, that may have not been covered yet. That's a gravitation chapter. There's
Or like,
have you done this before?
I feel like, I mean, I know that from like middle school, I think. I don't know. Like,
yeah.
I don't know. One of my teachers probably said it.
Yeah, well, it has to deal with this. So the force, the gravitational force between two objects, like an M1 and M2, is related by this equation. So it's this nasty constant, which I think is like 6.63 times 10 to the minus 34 or something. The mass of the first object, the mass of the second object, and then it's divided by r squared. R is the distance between the two centers of the things. So when we had here, right, the Earth and the Sun, this force of gravity we figured out is the same force of gravity we would get from G, M Earth, M Sun over r squared, where this was the r. You could calculate it. But the main point of this is that as r, so the distance between two objects, as this goes up, the whole force will then go down, right? Because you're dividing by a bigger number, right?
Oh, yeah.
Yeah. So that makes sense, right? Gravity is one gravity on the surface of the Earth, but as you're up in the sky a little bit, it's, well, a bit, 400 kilometers. It's 94% of what the original gravity is. Yeah.
Okay.
Yeah.
Yeah, I see.
Okay. I think there's like, what was it, one or two more or something? What's the?
Oh, there's one more.
One more. Which one? 6. Ooh, the Potter wheel. Okay, this is cool. All right, let's do it. Now explain r cubed t squared. That's actually where the pi r squared comes in, I think, Jeff. Yeah, Bella was talking about like her teacher, like, dude, her teacher just fucking wrote this, dude. Like, just wrote a equals pi r squared, but it has nothing to relate with this so far. This, I think, does relate, Jeff, when you talk about r cubed over t squared, because I think there's something where like the area of the precession of something is always constant. Is that right? One of my astro friends probably knows this.
I mean, we never used it, so.
No, you've never used this. This is one second. I'm just gonna where is it? There we go. Area of precession constant. Okay, the area traced out by an orbit is constant over time. Yes, thank you. Yeah, it is. Well, why don't we have a nice little picture of it? Area of orbit constant time. Yeah, where's this? I want like a nice graphic. Okay, here we go. This is actually what it is. Okay, very cool. Here we go. So this is it. So remember how I said like the orbit of the Earth around the sun is not a circle?
Right.
It's actually an ellipse. And even more so, do you see how it's kind of like goofy? It's like cocked, right? It's offset.
Yeah.
Yeah. Like the sun is like here. And we do this weird thing around. We go around in like an egg shape, like an ellipse. But there's a thing called Kepler's law, which says, do you see this shaded area here, right?
Yeah.
Yeah. So this shaded area is the same in a certain amount of time as this shaded area is. Okay?
Because...
Yeah.
It's
weird.
I guess I could see.
Yeah. It's weird. But, for instance, what it's saying, I guess, is that let's say it takes, 40 days to get from here to here. Okay?
Yeah.
It takes the same 40 days to go from here to here.
Mm.
Do you see how this is like a much less of a distance, right? Like in terms of the orbit. And that's because out here, you are so much further away from the sun. Right? And remember what we talked about, the force of gravity being related to how far away you are from the thing? So because you're so much further away, you don't have as much of a pull, which means your velocity going around is less.
Right.
Yeah, that's where this all comes from. Just extra little tidbits. Make science fun or something. I don't know. Okay. What is the magnitude of acceleration of a speck of clay on the edge of a potter's wheel turning at 45 RPMs, revolutions per minute, if the wheel's diameter is 32 centimeters? Or maybe it's pre-Kepler? I don't know which one it was. Okay. Let's do it. So we got a wheel, right? And we got... Well, that's a very... Okay. And then we got a speck of dust. Okay. And it's moving around at 45 revolutions per minute. Okay? So, what do I want to do with this right away when I see revolutions per minute?
Change into seconds.
Good. Change it into seconds. How do I change it into seconds? Uh-oh.
Oh, yeah. Wait, no. It is times 6. Wait, divided?
Okay, this is what I always like to do. Times, right? And then there's always some factor here, right? Where this factor is always equal to 1. Okay? I'll show you how this works. Like, let's say, for instance, right? 12 things is 1 dozen. See how, like, these are the same things?
Yeah.
Right? 12 things is 1 dozen. So it's like multiplying a thing by 1, which doesn't change it, right? If I were to multiply this number by, 9 over 3 squared, do you see how that does not change what this number is? Because I'm multiplying by 9 over 9? Yeah, okay. We're going to do the same thing here with minutes and seconds and stuff. But what you know, right, is that 1 minute equals 60 seconds. So as a conversion factor, that can either be 1 minute over 60 seconds, or it can be 60 seconds over 1 minute. But which one is it? Right? If I plug it back into here.
Can I guess?
Yeah, let's guess. Well, you know what it is. Just tell us what it is.
Can I guess the first one?
You know
Before
you know what
starting
it
my
is.
journey at WGU, I transferred from a community college.
Why do they put
Gave me
ads
the
now
chance
on
to
the
get my
lo-fi
foot on
music?
in the door, and I didn't
That's so
purposely
annoying.
leave.
Okay, anyways. Well, I need to unmute it in a second. Okay, there we go. Now we're back. Okay. Okay.
Is it the first one?
You think it's this one?
Okay.
I think you're right.
My man.
Okay, because look, 1 minute, 60 seconds. Do you see how these cancel out? Yeah. Which now gives you revolutions per second, which is what you wanted. Okay?
Yep.
So that's the trick. If you ever forget whether I'm supposed to multiply or divide, right? Just see which one cancels out the things. Why are you using light mode YouTube? Oh man, I'm gonna get judged. This isn't my I don't use this PC for things besides streaming. Yeah, it's kind of and gaming, I guess, but so I don't have any of my customization things on it. Yeah. My eyes. Yeah, what's up, Raven? Good to see you. Oh yeah, dude, I didn't shout you out, Penn Center. Sorry, let me shout you out, dude. You had a stream today, yeah, Penn? think it was. Yeah, if anyone ever wants to know, whenever we're doing other awesome math stuff with our math streamer friends, there's a calendar that Penn Center set up for us. We love this. And you can see what all of our fun math streamer friends are doing during the week. So I think today, yeah, look at this. Penn Center and Zach, the 2iPi, had a linear algebra thing at 8 a.m. my time. That's really early for me. But for the East Coast people, not too bad. And then tomorrow it looks like Zach's going to do Infinite Series. So cool. Awesome. Love it. Yeah, Zach and I did the with an interested student. Okay, cool. Okay, they want it. Yeah. I need to figure out times to stream for the European people because it's super late for them right now. But yeah. Oh, so Penn, you woke up at 8 a.m.? Oh, wow. I'm sorry. Raven says it's 1 a.m. over there. Yeah. We actually have a whole keyword thing for this, I think. I think if I say time UK, there you go. It's 12 a.m. for our friends on the other side of the room. Oh, you had to prep. Wow. Good for you. Good for you, Penn. You're a better man than me. Okay, cool. All right. So we know 45 revolutions per 60 seconds. Awesome. Okay. And it wants us to figure out. Okay, and then the other thing they tell us, right, is the wheel's diameter is 32 centimeters. They're trying to mess with us a lot here, right? They're just trying to just screw us up, right? Like
I did do I turn it into like 64 or something?
Close. So diameter. What is diameter, Bella?
Like half of the. Oh, it's the. Okay.
It's the total distance across a circle. Yeah. So what's the radius?
Times 2.
Times 2.
Wait.
No.
Like the diameter is times 2.
Oh, the diameter is times 2 of the radius. Okay, good. Okay, thank you. Yeah, you're actually correct. Okay, good. Yeah. The radius, right? There are 2 radii in a single diameter. Okay. Jesus sensation. 2 grams of fat. Dude, stop. So you divide it by 2. Yeah. And then even more so, right? What is centimeters? We don't like what is a centimeter? Yeah. We don't like that, right? I want to write that in meters. That's the key thing here, yeah?
16?
0.16. Good, yeah. This is 0.16 meters. Cool? All right, so now we got our stuff, yeah? Okay, so acceleration, centripetal, equal to v squared over r, which we remember from this equation. What's up, math major? Evening to you. I guess early afternoon for me. Evening to the East Coast people. So let's just use this formula. I don't know. I kind of like this formula that we came up with. It's just easier. But you can always get it from here. Okay? So we're going to say 4 pi squared r all over t squared. Okay? Which now we know 4 pi squared. The radius, right, was 0.16. And then the time, oh, I screwed up. This t has to be the time for 1 revolution. Okay? Okay. So
do I...
You good? Keep thinking.
Do I square root or something?
Yeah. That's square root or something? Okay, so yeah. Okay. This is called the frequency because it's the number of revolutions per second. Okay. When we use t here, this needs to be what's called like the period. Okay. Do you remember the relationship between frequency and period? Have you done this before?
I don't think so.
I don't think you have, yeah. It's okay. So frequency is equal to 1 over the period. Have you seen the word period besides like English class or health or something? Have you seen this in like physics?
No, not in physics.
Okay. Period is the amount of time it takes for something to do an oscillation.
Is
Whereas,
this in, like, pre-calc or
it is. It is in yeah, when you guys do like sinusoidals, like this stuff.
Yeah.
Right?
This
is called a period. Yeah.
Yeah, that's
You see how that's the amount of time for it to do one oscillation?
Yeah.
Yeah. It's related to the frequency. They're inverses of each other. Inverse means you just divide 1 over, right? Yeah, okay. So 45 over 60 which if I wanted to simplify that, right, divide by 15, that's 3/4. That's equal to the frequency. What does that mean the period's equal to?
4. Wait, where
you had
did
it.
the 4?
Where did the 3/4 come from? Is that what you mean?
Or like, are you just pulling out like a
Yeah. So I'm taking this right here.
random?
No, no, I'm not taking random numbers yet.
Oh, I thought I was.
She's like, not random today. Okay, so 45 over 60.
Nice.
You can simplify that, right?
Oh, it's 3/4. Okay.
That's 3/4. You can also think about this, right? 45 minutes out of 60 minutes, an hour. 45 minutes is 3/4 of an hour, I guess.
Okay.
Or does anyone ever say like quarter till? Or quarter
Yeah.
past? Yeah, maybe. I don't know. Yeah. What's up, Milos? Appreciate the follow, dude. Milos, Meloxis. Oh, that's a cool name. Okay, so if 3/4 is the frequency, what's the period?
4/3.
4/3. Yes. Okay, cool. So I can plug that into here. So this is gonna be 4/3 squared. Okay. What's up, Fembox? Good to see you.
Wait, so would I not do that for any other? Is it just
Yeah.
like this one?
So yeah, if you
specifically, or-
want to see, you want to see like when your teacher did this question, I guess, right? So let's see. They did so many questions of what they did. Yeah, okay. This man. Penn Center, I think you've done this before. Or no. This was Phobos that was doing it, but it was you announced on your calendar where he did like a roast of someone else's code. I could just roast other teachers in how they're teaching because there are so many confusing things with this. What's happening? So first of all, he's trying to calculate a velocity here, right?
Right.
But this is so confusing to write it this way because really what he needs to write is that v is equal to, I guess, like r omega, and then omega is like 2 pi over f and stuff. He just multiplies 2 by it. He just doubles the velocity because he says, oh, it's 2 revolutions per second. Yeah. Do you like mudkips? I love mudkips. Okay. Yeah. He's not using period here at all. Do you see how he does the 2 pi r here? He does the 2 pi r for sure. But then when he does like the divide by t, he does 1 over the frequency kind of like, so this t here, right? It's the same thing as
converting it or something.
yeah, he is kind of. So look, so it's 2 pi r over the time. Okay. This is, sorry, let me thinner. This is the time, right?
Yeah.
Okay. But the time is equal to 1 over the frequency. Okay. So if this was 1 over frequency, that's the same thing as putting it on top as multiplying by frequency over 1. And the frequency is here. That's why he's multiplying it by 2.
Oh,
2 revolutions per second. Yeah. Yeah. That's where it's coming from. He should have said that. He didn't. He just arbitrarily just multiplies it by 2. Yeah, I don't know. Okay. Anyways. Someone stole a mathematician's gold. He said, I want my gold block. Wow, that's actually pretty funny. Okay. All right. Cool. So frequency. These are also, it's also good, Bella, just to get into the habit of using these names for things. Because frequency and period are going to come up a lot later in other physics classes. And you want to be comfortable like working with them versus just arbitrarily being like, oh, I just multiplied by 2 because they gave me this thing, you know. It's like knowing what you're working with. Yeah, okay. Very cool. Yeah. Anytime they give you like RPM or hertz is the other thing you'll see. Have you seen this before? HZ?
Yeah.
This is equal to 1 revolution per second. So if something is, for instance, 11 hertz, then it's 11 revolutions per second.
Oh.
And that is a frequency. Anytime you have revolutions per second, that's a frequency, which you then do the reciprocal of to figure out what the period is.
Oh.
Oh, she's like, oh, there's too much math happening.
Surprise, motherfucker.
all I know is my monitor is 144 hertz.
Oh, cool. You want to know why your monitor is 144 hertz? You know what that means? Why?
Is it 144?
You're a gamer, right? So explain to me, why did you get a 144 hertz monitor if you're a gamer? Like, why would you get it?
Like, it looks
nicer?
I guess, or
it looks
faster,
smoother.
I don't know.
Cool, it looks smoother. No, it looks faster. No, that's cool. Yeah. Why do you think it looks smoother, and why do you think it looks faster?
Is it like the 144 per second? Or... Good.
It means that there is 144 refreshes of the screen per second.
Right.
Okay. So actually, this is pretty cool. A little side tangent. We'll get the math thing in a second here, but so if your frequency is 144 hertz, which is 144 cycles per second, okay?
Mm-hmm.
What would the period be then? 1 over 144.
Yeah.
Okay. Do you see how this would be seconds over cycles?
Yeah.
Okay, so watch what happens if I do 1 divided by 144. It's actually pretty cool. Where's my calculator? Yeah, what are you guys talking Japanese in the chat, dude? What? I mean, y'all can do whatever you want in the chat.
Chinese.
Oh, it's Chinese. Oh, okay. Mandarin or Cantonese?
Chinese. Mandarin.
Oh, Mandarin. Okay, cool. Okay, so this is 0.00069 seconds. Okay. Which this is the same thing. If I wanted to convert this is 6.9 milliseconds.
Nice.
Okay. Right. So that means the time in between your monitor showing another frame is 6.9 milliseconds.
Oh.
Okay. You probably know this from what? What number do you know this from in gaming? Where do you see MS?
Ping.
Yes. Ping, right? That's the latency, right? That's the amount of time it takes for the server to take what you did and then broadcast it to everybody else. You know? Right? It may there's probably some actual technical thing. I think it's maybe the average of the send and receive or something or whatever. But
wait, so what happens when like one person has like one ping and then the other people have like 20?
Yeah, there's issues.
Like
there's issues with syncing, right? Yeah. Well, what happens? Okay, so if for instance someone has a ping of like 60 ms because they're on like McDonald's Wi-Fi or something, and you have a ping. Not me, she says. And you have a ping of 5 ms, okay? That means that you will get 12 times the updates in the same amount of time that the person with the 60 millisecond ping will. Okay?
Okay.
So what happens is on their screen, they don't see anything change in those gaps, in those windows. Right? You can say like here there's like, like move, like shoot, and then like I don't know, like dead or something, right? But if your ping is 60 milliseconds, okay, let's say that this time here is 60 milliseconds, then you totally don't even see the shooting part. You just see that you're dead. Right? Whereas the person with the 5 millisecond ping sees all the things happening.
Right.
Yeah.
Okay.
So that's how servers work. If someone has really high ping and they start complaining, "Oh, my ping's bad, dog." Like it is hard to play with high ping because everybody else is doing things and you're not even seeing it.
Right.
Yeah.
Omega says,
yeah, go on.
I used to get 1,000 ping or like.
Oh, 1,000 ping. Yeah, that's a second.
9,000 ping on my laptop because I use my hotspot in school to play.
Yeah, that's not good. No, that's not good. Yeah. Omega brings up a good point. Yeah, latency is not a good example of period. 100% it's not. But they are dimensionally the same. Yeah. I wanted to show like where the millisecond thing comes in, because here's what we talk about is that your monitor, okay, if it's 144 hertz monitor, still takes 7 milliseconds to show new information. Okay.
Right.
It can only show a new frame every 7 milliseconds. So even if your ping is lower, like let's say you have super fast ping, like 2 millisecond ping or something, right? You're still only going to see new information every 7 milliseconds. It's and that, yeah, so it's it's cool to see like the limits on things and stuff. I think also the human eye refreshes at a certain rate, and it's not even this low. Yeah, but okay. So yeah, that's where the hertz comes from. It basically tells you like how fast your screen can show like a new frame and things. It's cool.
My brain is on 100 ping.
Your brain is on 100 ping. That's actually pretty good. Back in my day, we had dial-up for doing things. I would log on to like RuneScape servers, and I was happy if my ping was like 400. I was like, thank God. But that stuff's kind of more turn-based, I guess. It's not like shooter games were impossible. You couldn't do it.
I've got you beat.
You got me beat, Sensation. What do you got?
You remember floppy disks, the smaller floppy disks, right?
Yes.
3 1/4. It's even I can't remember now. 3 1/4.
Well, they're the big ones, right? I have the big ones.
Not 5 1/4. The smaller ones.
Yeah, the smaller ones. Yeah.
Anyway, they were 1.44 megabytes, right?
Yes.
In the early days of the internet, it took me 45 minutes to fill that up.
45 minutes. Jeez. Dude, like one of these images I upload just to the server to like is like 8 of those. 5 1/4 were the big ones. 3.5 inch. Okay, cool.
Right, yeah.
Yeah,
it's been a long time since I've even seen one.
Dude, it's nuts how far we've come in the last like 20 years. It's pretty fucking nuts, or 30 years, I guess, at this point. Anyways, you do this math here, right? If we do 4 pi squared 0.16 over 4/3 squared, you're gonna get 3.55 for your answer, and that's the acceleration of this speck of dust. Yeah. Cool. Does that make sense? Yeah.
Yeah.
Yeah. Good job, Bella.
That's dope.
Yes.
Do you know a fun fact about my physics teacher?
Yeah? What's a fun fact about your physics teacher? Please tell us. I want to know.
My friend, she's in the AP class, and like he hates her class because they're too smart, or like whatever. Like they're doing
like they're smarter than the teacher.
Physics. Like they're not smarter than him, but they're doing like okay in it. Like some of them are getting like A+ and like hundreds and stuff, and he gets mad.
Why does your teacher get mad that the kids are doing well? What?
He's like, this is rated the hardest course in the school. You guys should not be doing well. I'm gonna make the test 30 minutes longer than it should be.
Excuse
like
me?
we had a midterm. He's like, oh, I'm gonna make it 30 minutes longer than it should be.
So your teacher
and he
just
like straight up said that. Yeah,
Oh
he's
my
like,
God.
you guys should not be passing.
Okay, this is I have so many opinions about your physics teacher at this point. But, what? This is so it's interesting. I think I did get hired at UCLA. I don't know yet. Well, they assigned me a class Monday, Wednesday, Friday, starting in March for physics.
Are you like a professor?
This would be a lecturer. Yeah, professors are a harder thing. I teach the same class that a professor would teach, but I don't get paid like a professor. Because professors require research money and stuff. But yeah, basically. But there's a bit. But the class I'm teaching is for pre-med. For thanks, Fanbox. Yeah, I haven't signed, so I'm pretty sure I have it, but I'm not celebrating yet until I sign a piece of paper. But yeah. But anyway, sorry. Yeah. So pre-meds get really particular about their grades because grades are like the most important thing to them in order to get into med school. And when I was meeting with the department for possibly teaching this class, they were saying, so yeah, you're teaching pre-meds who are really weird about grades and stuff, but we need you to be like harsh. Because what'll happen is there's definitely a problem in the education system with what's called grade inflation, which means that teachers are just giving all A's to their kids in order to make the kids happy. Also, it makes the school look better if the average GPA is higher, and it makes the teachers look better because, like, wow, you have so many smart kids in your class. The problem is that the kids, aren't actually learning, right? They're not, they're getting all A's in the class on paper, but they don't actually have like an all A's performance in the real world, and so it creates this like huge disconnect and stuff. When everyone's smart, nobody is. Yeah, so. I say my philosophy is you should make exams difficult, right? But only to the extent that if everyone gets 100 on it, you shouldn't put like a negative curve. Like, you don't need people to fail. If everyone's understanding what you're doing and they're getting the answers correct, then you did a good job as a teacher, you know? Usually what happens is everyone fails and then they have to curve up, is what it is, because yeah. But then that's demoralizing.
He likes my class because like most of my class is failing.
Yeah, well,
but
okay,
but he likes me a lot because
Yeah.
I don't like, I'm not failing, but I'm not doing like, I'm not getting hundreds.
That's fucking
So,
weird.
like-
This is like some Munchausen syndrome thing or something. What? Like, or Stockholm syndrome. Like, I want my kids to like suffer so that they need me. What? Oh, such questions. I mean, I will go through it when I end up teaching this class. I'm because I have to write the exams. I have to write physics exams, but it'll be interesting because I haven't ever really written an exam for a class and then given it to them. But my philosophy is I'm going to make the exam such that it tests, do you understand the concepts you're supposed to know? And it doesn't need to be overly hard in order to like discourage people from getting good grades, but it's not going to be so easy that, you know, if you didn't understand the information, you still got an A. Yeah. Femvox says, this is why I'm such a huge fan of standardized testing, because people getting D's, and I wonder what on God's earth the instructors are saving the F's for. Yeah, right? Yeah. From a school point of view, it's also bad because it's getting harder and harder to identify students that need help. I agree. Yeah, grade inflation is an issue for sure. Yeah, because if everyone's doing great, then we don't know who actually needs to get more help with things. Teachers are both under scrutiny and are judges. Then the grade inflation, non-homogeneity. Yeah, okay. Examinators and teach-only teachers. Yeah.
Is a 57 passing?
Is a 57 passing? Well, according to the AP exam, that's a 5.
Really?
Yeah, on AP Physics, yeah, a 5. Yeah, you want to see the AP exam breakdown for physics?
Oh no, I meant like for stats. Wait,
for AP
that's
stats?
a 5?
You know, I'll show you it. Yeah,
AP stats.
Where's the grade breakdown? Why do they make this so hard? There we go. No, that's this. Where's the... I want like the raw score. What was it like? Breakdown.
Do like score?
Yeah, score maybe? Yeah. There's something where it shows what you would have to get. Okay, but anyways, so in this case, if you got a 50 on everything, okay, that's a 3. So that's passing for AP Physics 1, apparently. Yeah, getting... Oh, here we go. Here's something. This is probably old, but whatever. We'll take it how it is. So, yeah. So, for Physics B, if you got a 59 on the exam, that counted as the highest marks for it. Yeah. It's super fucking curved. It's nuts. Oh, thank you, Equity there. And it changes for different things. So, yeah, because AP Physics is one of the hardest classes, that's why. But AP Statistics, grade.
I would think it's like a 2 or a 3.
All right, maybe this link, sorry, that Equity sent me is actually okay. 1 second, let me check this. Here we go. Cool, awesome. There we go. Well, okay, this is the percentage of people that got that grade. So it's not exactly what it is, but yeah. But for, they call this math and computer sciences?
Go back to the English one. That was fucking hilarious.
What, English? What are you talking about? This one? Yeah. So more.
That was me.
Yeah. So for
I got a
3
2.
plus. Okay. So here's what they're saying. Yeah, they're saying for English, 28% of the students get a 2. So 54.6 at least pass. But then for literature, ELA, yeah, it's 72. Yes. Good luck, Omega Ken. You have to teach college-level physics remotely tomorrow. Ooh, wow. Okay. Yeah, good luck with the if you Omega, if you ever have any questions about teaching physics, feel free join our Discord if you want. That's the easiest way to like send me a DM or something. I'm Dr. Gold, that's me. but I'd be more than happy to, if you have, for instance, a question that comes up from one of your students, or you need to explain a topic, I probably have a video on it. First off, that's what Bella was talking about earlier. She recommended me to like her teacher or something. I make TikTok videos on all the hardest things, not the hardest, but the most commonly screwed up things in physics to teach. Like, for instance, I did this one on centripetal circular motion and centripetal acceleration. Yeah, this Bella will get into the thing with talking about how you weigh more in a roller coaster at the bottom than you do at the top. Yeah.
Yeah. Oh,
so
like the water bucket thing?
Yes, exactly. So, there's all the stuff. Oh, I gotta give you a bond coin too. One second, let me do that. So yeah, if you ever want to watch that video, that'll help out with how centripetal acceleration works. It's a pretty long video. It's a 3-minute video I put out, but yeah. Anyways, TikTok light mode. He hates all my light mode stuff. What's up, Sensation?
It was a bit simpler for us. I mean, in GCSE physics, we were told to stand in an elevator and stand on a set of scales.
Okay.
Then we go up, and we go down.
Yes, yeah. That's the elevator question. That's 100% the elevator question, which I want to say I did at some point. I did do it. What is it? I don't know. It's somewhere in my massive thing of things I've done. But anyways, you guys don't like the light mode? Chill. Y'all need to see the light. Okay, cool. Yes, Will Shantrix. I'll do yours next. Anyways, Bella, feel free to hang around in the chat if you want, but otherwise, thanks for asking your questions about things. Hope it helps.
Thank you.
You're welcome. Yes.
はい、日本語授業始めます。
始めます。Taking scales into an elevator, hardcore experimenting. It's one of the funner things to do, honestly.
It was right at the beginning. It wasn't like, the middle of the course or whatever. It was like the first week.
This is why I like teaching physics, because it's real world. You know, you can say, hey, have you ever noticed you feel lighter in an elevator? Like, yeah, man. You're like, this is why. So what's up?
You have been living in LA too long.
I have been, I know. Math Major says...
like totally gnarly.
It's gnar, bro. Math Major says you just need to be a week ahead of your students. So that's literally me with tutoring. I just need to be 5 minutes ahead of my students. When I used to tutor, I would prepare so much. I would say, hey, send me the homework questions ahead of time, and I would do them before I met with the student to make sure I knew it 100%. But at this point of tutoring for like 15 years, I just go in blind, and I say, whatever. I have enough confidence in myself that I know I can figure out whatever the student doesn't know before they figure it out. And then that's tutoring. I think it also works better because then you're coming at the student from a point of view of teaching how they're learning. Like, you're both learning together, but you're just showing them the process of how to learn faster. Versus being like, I already know this, why don't you know this? There's kind of a disconnect. But if you say, hey, I don't know this either, but here's how I would go about knowing this, then then they learn it more authentically, I think. Ideas.
Come at them from the perspective of questions rather than answers.
Correct. Exactly. Yeah. Someone says, yeah. That's called Socratic teaching, by the way. I think. Is that right? Sensation Socratic?
As in Socrates.
As in Socrates. Yeah. As in Socrates.
There's a Socrates book over there. I can't reach it though.
There was an interesting... We were playing Jackbox the other day with my friends, and one of the Jackbox questions was, what percentage of people have read less than half of the books on their bookshelf? Do you qualify as one of those people?
Oh, I've read every book on my bookshelf.
Oh, good. Good for you, Sensation.
Well, actually, no, that's not entirely accurate. I still have not got all the way through War and Peace.
Oh, War and Peace. Oh, that sounds like a bender, dude.
It's like that. It's like that fat.
Yeah. Oh, this is nice. Omega says, I like you both, but what I'd like most is a K number in front of your viewers. Yeah. If we change this to actual feet, maybe we would get in the Ks,
Actually feet.
Actual feet. Yeah, maybe then we would have Ks of viewers. Yeah, right now, I'm cool with 23. We're actually doing pretty well.
Good job.
It's one of the bigger streams we've had today. Yeah. Sensation's about to boost our channel views. Up the fucking...
I can't even reach my fucking desk with my feet.
Yeah. Like and subscribe. All right, let's see. Let's do Shantrik's question. I think this is a math challenge. He said no calculator for this one, by the way. Two lines with equations. This looks like linear algebra, maybe, yeah? Are perpendicular and intersect at a point on the y-axis. What is the value of D? Oh, this is an SAT question, bro, I think. I'm pretty sure I've seen this as an SAT question before. Okay, cool. Yeah, good to see you punching and stuff. Yeah, Femfox knows discrete. I want to learn discrete. Did someone do a discrete class at some point? We have a bunch of really fun math streamers that run courses. These are the courses up so far. So there's a linear algebra, intro calculus, and infinite series. Are we? Yeah, you have more in the cool. Yeah, we have this one. Yeah. Oh, we have tons of questions. Yeah. Yeah. Just for those that have just found me or found us on Twitch, we have a Discord here. The link is right below my picture, and you can also type Discord in the chat. But the students we have in our server submit screenshots of their homework questions and stuff, and we go over on the stream live. That's the whole model. It's pretty cool. Okay. Thank you, Sensation. Yeah, that's the link for it. Yes, exactly. Yeah, and the other way we do this, Omega, is I will answer a person's question, and then I try to connect it to other things so that those watching that it's not their question still learn things. It's like a social learning fun thing. Education's fun, but actually
just sit here and talk shit.
Yeah, Sensation is our. You remind me of the guy in like a talk show who's like with the band and like just saying like the funny things and stuff. Do you guys have this in the UK? Yeah, triangle, like ding 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 ding.
The Graham Norton show. He has like a band.
Yeah, it's like a band, and then there's like another guy or something, and then they kind of.
Actually, it's 4 puffs and a piano.
4 puffs and puffs. Oh, that's a word. Okay. Our perpendicular intersect at a point on the y-axis. Cool. So if something intersects on the y-axis, the y-axis, just for a little reminder here, right? This is x and this is y. That's a bad y. There we go. The y-axis means that x must equal to 0. Okay. If I'm on the y-axis somewhere, must be at x equals 0. Okay, cool. So I know the intersection has to be 0, something. We don't know that yet. Okay. And we know that they're perpendicular. So another fun thing about perpendicular lines, this is the word for perpendicular lines, is that the slopes are the negative reciprocal of each other. Ordinate. What does ordinate mean? Anyways, I'm just gonna write these in like slope intercept form and like see what happens. That's the way I would attack this. So if I were to rewrite this, this would be 6y is equal to 2x plus 42. Okay. And if I divide by 6 on everything, right, that gets me y is equal to x over, so I'm going to say 1 over 3x plus 7. Okay, cool. I like that. That's my first line. My second line is gross because I have a bunch of variables. Okay. So, what's that? Ky equals negative 15x minus d. So y is equal to negative 15 over k minus d over k. So all I did is I took this and I put it into slope intercept form because I think I'm gonna come up with something cool here. Oh, I forgot an x here. My bad. Okay, x. Right? Anything else wrong here, Jeff? Have I done anything wrong? What's doing something wrong? Okay, cool. All right. So then we have this. Jeff says, huh? Huh? I was taking a nap. Were you taking a spherical nap? Minus d over k. Thanks, math. All right, cool. All right, so I got two equations here. So what I know is that if these lines, okay, so if these lines are perpendicular to each other, then these slopes must be negative reciprocals of each other. The slope of this one, right, of this first one here, or let's use a different color. This is equal to 1/3, right? Which means that the perpendicular slope needs to be negative 3, okay? This slope is already negative 15 over k. So that tells me right away, in order for this slope to be negative 3, so that's perpendicular to this, I need k to equal 5. Cool. Already got one of our solutions. Doing great, yeah? Okay. So I can replace that k now in everywhere, which would be nice. So let's just do that. So I'm going to get y is equal to negative 3x minus d over 5. You have a song recommendation to play in the background. It's a pretty chill song. Yeah, the issue is with that, guys, if I play actual songs, then I get bopped for copyright. I know. Maybe if we register this Twitch as a DJ channel, it would be cool with that. Anyone see this? They have like Twitch for DJs, which is funny because I do DJ. The Twitch. Do you think should we sign up for the Twitch DJ program, dude?
How do you get away with that though?
Well, because again, then this is a big argument. Like as a DJ, you're helping people, artists, because playing their music gives them exposure, which means people are more likely to listen to them. So this is like a way. Yeah, here you go. DJs are they are a very special kind of content community creator, whatever people. Yeah, okay. They're wildly successful offline, but have historically faced serious challenges. Blah, blah, blah. Yes, rights and licensing. And so, yeah. They allow for you to play music without it getting bopped by all the recording companies and whatever. So yeah, maybe we'll become a DJ channel.
Putting some banging tunes.
Oh, they can't post VODs? Oh, fuck that. All right, we're screwed. No, we can't do that. Nope. Nope. All right. So this is our new equation of this line, and I still have this, right? Y is equal to 1/3 x plus 7. The other thing I know, right, is that these two lines intersect at a point on the y-axis, which means x is equal to 0. Okay? And if 2 points intersect on a line, or if 2 lines intersect at a point, sorry, I said that backwards. If 2 lines intersect at a point, that means it's the same point for each equation. So the y for this line will be the same as the y for this line. So I can just set these two equal to each other. So I'm going to say negative 3x minus d over 5 is equal to 1/3 x plus 7. Okay? Say this is like line 1 and line 2. In order for these lines to intersect, these y's have to be the same. Now we get here. And I know that when they're the same, where they intersect, that the x coordinate is also equal to 0. So now I can just get rid of the x's here. Right? Because I can just plug in x equals 0. So that goes away. Nice. Let's get rid of this. Let's get rid of this. And then you get that negative d over 5 is equal to 7. Multiply both sides by negative 5. I get d is equal to negative 35. And I think that's the answer. Is that Shantrix? You can play sets, but the VODs still get those weird silent areas where copyright songs I tried listening to sets one time for VOD. It was like 15 minutes. Oh, that sucks, dude. Yes, sir. Nice. Okay. Raven says, why did we calculate K? Okay, we had to, because originally when we had our 2 lines here, Raven, we didn't know what K was. So this was my equation of, well, here. Yeah, I kind of messed them up. Sorry. This is now line. This is line 2. And this is line 1. Yeah, you get it. Cool. Yeah. We had to solve for K such that we just had 2 things in terms of X and D, and then we know what X is, and then we're done. Yeah, nice. Cool. Oh, this was a Waterloo question? Oh, okay. Canadian Team Mathematics Contest. This one was not too bad. Wait, what number was this? Go team section. Yeah, I kind of like the team section. Sorry, this was question 6. Okay. Dude, what? Excuse me? Wait, this sounds a lot different. Are you sure this is the right solution? Oh, go to the team section. Oh, my bad. Sorry. Relay problems. Is the relay like the team as well? Here we go. Team problems. Oh, okay. Here we go. Yeah. Yep. Same thing. Cool. Nice. How many questions are on the team section, by the way? I see 8, 9, Do they go up to 25? They do. Okay, cool. That must be difficult, man. Like, when you give me the super hard math questions, that's me as one person. Like, as a team, how many people are on a team, first off? And also, how do you delegate people to do things? Like, how do you solve a math contest in parallel? Do you say, like, hey, you're going to do the cases 3 through 6, and you're going to do the cases 7 through 10 or something? Imagine Golden Pen on a team. Oh, Pen. I like to think we are a team. We're like a virtual team, separated by thousands of miles, but together under the digital platforms. But yes, if we were on like a trivia team, I'm pretty decent at trivia, actually. Oh, it's actually grade 9 and 10. Oh, wow. Yeah. Cool. All right. Nice. That was a good question, Shantrix. I like that. What else we got? Ooh, I like this. This is a good question by... this is going to be a Darsh. Thanks for waiting around, Darsh. I know it's been taking a little bit of time. Says, I've seen students do team sections by splitting up the work on the questions or work on a particular question. Okay. Yeah. It must be interesting. You need like a worker person to be like, I'm the delegator, and so we know that this question is, like, I don't know, like 10 different permutations of things. So y'all work on these cases, y'all work on these cases, y'all work on these cases. Yeah. You need a manager. Then math goes corporate, dude. Okay, let's do yours, Adarsh. Okay. Says if 240 over 80,000 times 6,000 over 900,000 is equal to this, what is the value of n? Okay. That's not too bad. You know how to do this, Adarsh. How do I do this one? Something corporate, yeah. I'm an HR nightmare, by the way. It would be a good band. Is that our new band name? Is that our team together, Penn Center? Are we something corporate? Oh, you gotta... Oh, that's fun, Shantrix. Nice. Coding solutions. I like to try to simplify these things. I don't know. Maybe. It's already a band? Oh, damn. They already took our name. Do you know the band MGMT? Which is, that song. Don't copyright me, please, Twitch. Yeah, so they originally called their name MGMT as short for the management. I think they were making fun of like a band having management, and so they called themselves MGMT. I didn't know that until like kids. That's what it is. Yes.
I was going to say performing a song wouldn't get you copyright stricken anyway, because it
correct.
The copyright would then belong to you as the person that's actually doing the song.
For the performance of it, right? But I don't think you can just straight up take someone's song and then sing it yourself and then get money off of it, like as a record, right? Isn't that copyright for like lyrics and stuff or something? You need a mechanical license. Oh, that's what Jeff says. You need a mechanical license.
Mechanical.
I don't know that. I don't know. Jeff, are you like a music lawyer? You didn't tell us that, dude. That's cool. Yeah, Reki, you recommended it, but I explained earlier, Reki, that we can't play like just any song on YouTube because they'll flag my channel. Yeah. I just randomly say stuff. Mechanical license sounds right. Okay. Anyways, I'm gonna cancel out some zeros. So anytime you got zeros on the top and zeros on the bottom, you can get rid of them. So 0, 0, 0, 0, 0, 0. And like maybe it just makes things nicer. Let's see if there's something like kind of cool here. So 24, 8. So now we have 8,000. Okay. 8 with 3 zeros. Times 6 over 900. Okay. Okay. I can pull a 3 out of each of these things. I can really pull a 6, but I want to explain how I would do it as if I were like a high school student, okay? I would recognize that I can pull a 3 out of a 6, and I can pull a 3 out of the 900. So that will change this into 2. If I pull, oh here, I'll do it on the same line. Give me a second, sorry. Okay. So I could divide this by 3. I could divide this by 3. And I could also divide this by 8, and I could divide this by 8. So that would get me 3 over 1,000, okay? And then this would get me times 2 over 300. Very cool here. So here's actually a really cool thing with math. It's called the, I want to say this is the commutative property, but we know when multiplying fractions together, right? You multiply top times top, and then you do it over bottom times bottom, okay? So that's the same thing as 3 times 2 over 1,000 times 3,000, or times 300, sorry. Did someone say math? Right, so 3 times 2 is the same thing as 2 times 3. Yeah, this is called, I think, the commutative property of multiplication. So I can rewrite this as just 2 times 3. And then I can re-separate these as fractions. The reason why I did that is like, you know, this is kind of like, it's like it's like these two fractions were tangoing, and then we just like, we partner swapped or something, you know? What's up, Neil? What's your, Dr. Gold, I have chemistry. I love chemistry. Chemistry is great. Do you have any questions about your chemistry final, dude? Oh, cool. A cover song, Jeff. Yes, that makes sense. Nice. You could call it an abelian property if you wanted to sound fancy. Yeah, wow. The problem is, like, when I use those words, those tend to scare off the high school kids. If I say, like, you know, an orthonormal, iso, homo, whatever thing, they start calling me names or something. So, we'll
you mean adding like, 2 numbers together?
You don't do cross-canceling?
Yeah, what's the most obnoxious esoteric term you can think of for just adding 2 numbers together?
Synergy.
Yeah.
Synergy.
We've got to synergize these numbers.
Raven says, you don't do cross-canceling in the USA? We do. But, you know, yeah, you could cancel this. We do, but I kind of want to show why it works. Because then this is easy. So then if I divide both things by 2 here, that gets me 1 over 500. If I divide both things by 3 here, sorry, this is divide by 2. I'm just showing all the steps. But you are right, Raven. I think we do teach cross-canceling. But sometimes when we teach these tricks, if we don't teach why they work, students tend to mess them up. The biggest one, I had this the other day with a student, is if you do, for instance, like a to the 6th times, like, I don't know, like b to the 3rd, right? They think this is like b to the 18th, or no. One sec. Sorry, it has to be the same thing. They think this is like b to the 18th, which is wrong. And I'm like, no. You add these. And they're like, oh. So we could tell them to memorize that fact, or we could say, oh, this is the same thing as a times a times a, right? And then this is the same thing as a times a times a. And it's like, okay, look, how many a's do you have now? It's like, cool, oh, I have 9. Okay, so that's a to the 9th. Yeah, right? The other big one that I see students get wrong is if they have like a to the 3rd times like b to the 3rd, they think this is like ab to the 6th, because then they multiply these but they add these, and I'm like, no. This is the same thing as a times a times a. This is the same thing as b times b times b. And if I put these together, right, that's the same thing as ab all to the 3rd, because look, I could pair them up. That's the same thing as ab, ab, ab. I don't know. I think if we showed more of this in math, it would stick better. Memorizing rules just sucks. You don't want to do it. You know, it doesn't stick. Yeah. You know what they say when you're right? You're right. Too much. Okay, anyways, Adarish, getting back to you. So once we got to here, right, now things are really nice, because I have 1 times 1. Cool, that's just 1. I have 500 times 100. So whenever you have this, you just multiply these two numbers together, which gets you 5, and then you count the number of zeros. So that's 4 zeros. Okay. Cool, right? So I have 1 over 5 times 10 to the 4th is what I would say. And that's what they have here, right? So this is 10 to the 4th. And yeah, you're done. That's how it works. Yeah, you're welcome, dude. Yeah, Omega says try with examples. Yes, I'm a big proponent of that, except powers of 2 suck. Because this is the problem. 2 to the 2 is the same thing as 2 times 2, which equals the same thing as 2 plus 2. So if you use 2 to try to do test examples, you don't really know which one it is. Kind of like, kind of hurts. So yeah. I totally agree with you, Omega. And I do tell students, I say, try to do test cases. You know, try to do like, what's like 3 to the 4th, or well, something easier. I don't know. 3 to the 3rd to the 2nd or something. And, well, no, that actually sucks too. But anyways, you get what I mean. Like, you start trying to do test cases, but using 2s can get problematic because all of these things equal to 4. Yeah. I love scientific notation. I do too. Yeah, it's cool. Understanding the limits. Yeah, of course, Omega. Yeah, you're right. Yeah. I'm just saying it as a warning. Use 3 or higher. Don't use 1 either, right? Because like 1 times 1 is the same thing as 1 squared, or 1 squared, I guess, or 1 to the 1, but it doesn't equal 1 plus 1. So I guess that's cool. Anyways, okay. Let's see. What's the next question up on the docket? We got Ayush. Ooh, looks like we're doing statistics today. I like statistics. I think statistics is fun. Ooh, yeah, bases of 10. Yeah, that's a really good one there, math major. Yeah, bases of 10. Yeah. What up, Cosmic? Good to see you, bro. Let's crack a lacking, dude. I haven't seen you in a second, dude. Hot second. Yeah, long time, dude. How's life going, Cosmic? What's going on? Are you in college? You in high school? I forget sometimes. Classes? Yeah, classes be classes. You're in college? Oh. Wait, did we give you the achieved college role yet? Oh, here, I'll give you the achieved college role. There you go. Yeah. You achieved college. You get a nice little fancy thing next to your badge. That's cool. What are you studying in college, Cosmic? What's up, Neil, dude? Neil, are you good? You good, dog? Computer engineering. Nice. It's a good thing to get into. Yeah, tech and IT is great. I mean, Nvidia stock is really down today, but I have hope for the American tech sector. Oh, you took E&M. Cool. How did E&M go? That's one of my favorite classes. E&M. It's a fun one to teach too. It's a hard one though because things aren't as easy to visualize, I guess, for students. So, like, you can't really visualize a magnetic field. I mean, you can, but it's much easier to visualize throwing a ball in the air and seeing whether it hits the basketball hoop or something. You passed with 100%, 20%. Nice, dude. We love that. Nice. Reki, okay. All right, here we go. So, Reki, here, we're going to do your question. Says this table gives the Aboriginal population in 151 metropolitan areas across Canada based on answer me, Leaf people. Does Canada call their natives Aboriginals? Is that what they say? Like we call ours like Native Americans. Is our term. Is there like Native Canadians, or is it kind of how like Australia calls them the Aborigines? Oh, Inuit. Yeah, right.
Aboriginal means wandering population.
Aboriginal means wandering. Oh, I didn't know that.
Which is weird because you'd think Native Americans would also be a wandering population.
But sensation, not all those who wander are lost. I may feel lost at times, but not all those wander. I got you. Yeah, you're up a little bit. Dude, Penn Center says Aboriginal is offensive nowadays. God damn it. I thought Trump was supposed to fix this, dude.
Well, you know what I'm calling everyone now.
Only nice things, Sensation. Aren't they from Australia? Yeah, are they? Yeah. I don't know.
That pisses me off.
First Nations?
Well, yeah, because they're not the First Nation, not even close. I mean, they were always Aboriginal by nature, so they were never a nation of people.
They were never a nation, right? Yeah, yeah, exactly. Yeah, nation I think is like a construct of like governments and things, right?
Well, what was the first? What was the first?
Well, no. I mean, there were the Indian nations, right? Isn't the Sioux Nation like a thing? They called it that, right? Like the Cherokee Nation. But I think they only started using the word nation because it was like a westernized word. They probably just called them like tribes. Yeah. First Nations.
Conversely, I'll tell you what kind of pissed me off. You know, when it was like, oh, these historically famous natives, and they give them like really English-sounding names. It's like, but that's not his name though.
Like Littlefoot or like,
things like that.
Crazy Horse.
Yeah, and it's like, but that's obviously not the dude's name.
Yeah, it was pretty badass though, dude. You imagine me calling Crazy Horse dog? Like what? Okay, let's try to do this question though. Okay, use the table to estimate the mean population. Estimate what you did, or explain what you did. Sorry. Okay. What I would do, so these are ranges of populations. See how this is like 5,000 to 10,000, 10,000 to 15,000, blah, 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 blah. I would take the average, or like split down the middle of all the ranges, okay? So instead of this being 0 to 5,000, I would say this is approximately 2,500. I would say this is approximately 7,500, okay? Now, frequency means the amount of times that thing pops up, okay? So let's say, for instance, I was trying to estimate the cost of ice cream, and I don't know. Let's say that let's make a little smaller table, okay? And let's say we have dollars, and then F is frequency, okay? Let's say 2 places I found ice cream was equal to $3, or in the 0 to or whatever $3 range, okay? So that would be 3, that would be 2. And then let's say I go to one really expensive neighborhood in Beverly Hills, and ice cream is like $15. I don't know, maybe it's covered in gold or something. So that has a frequency of 1, because I only found one place. If I wanted to find the average of these things, right, I would do 3 plus 3 plus 15, right? So you add up all the data you have, right? And then you divide by the number of data points that you took. So in this case, the number of data points would be 3. All right. This, right, would give us 21 over 3, so the average would be $7. Yeah. Yeah, the midpoint, exactly. So how this worked, right, is I took right here the dollar amount and I multiplied it by the frequency. And then I added that to all the other ones in the table, right? Do you see how this was also like the dollar amount times the frequency? This was 15 times 1, effectively, right? This was 15 times 1. And this was effectively 3 times 2. And then I divided by all of the different data points there were, right? Which in this case was 2 plus 1. Yeah. Okay, cool. All right. So, we're going to do the same thing here. All right. What I'm going to do is I'm going to take, for instance, 2,500.
Deserves a fast and reliable connection.
Commercials, Jesus. 2,500 times 122. And then I'm going to do it for the other one. So this would be 7,500 times 16. So look, we're just taking whatever the midpoint is of this and multiplying it by the frequency. 1 second. Did this commercial ad skip? Yeah. I already paid Spectrum enough money, dude. Dude, my internet bill is like $90 a month. These motherfuckers just keep raising the bill, and they know I won't call in to cancel, because then they lower the price back down. I don't know. I'm just Sensation. How much you pay for your internet?
I'd have to check. 25.
25 quid? You pay 25 quid a month?
Hang on. Let me actually check.
Yeah. Actually check. Actually check for actual education. This is actual data we need to know.
Actual data for actual feet.
Yeah, for actual feet. Yes.
Nice.
Nice. Yo, thanks for the follow, dude. Strawberry Kirby. Ooh, Kirby's my nemesis on N64, dude. I play Pikachu. Sensation, what did you get? Did you get the amount you got?
It's gotta be in here somewhere.
Yeah. Anyways, here. Let's do. Where's my calculator? Okay, here's my calculator. Okay, I'm just gonna.
Sorry, 43.
43. Okay, that sounds better. That sounds more appropriate. Yeah, dude. It's like, I'm tempted. So T-Mobile has like 5G hotspot internet. So basically, they give you a modem that takes the internet from their cell towers, and they're only charging like $30 a month. So it's like a third of the price that I pay to Spectrum right now. But apparently, it's bad for gaming because I think of how the cell towers work. Like the ping is terrible. And I still do like the game, so like, yeah.
No competition.
Yeah, there's no competition.
No, I mean, is there no competition for?
Oh, for my internet? Yeah, no, it's fucked. Yeah, no, if I wanted to, because it's how the apartment complexes work. They, for whatever reason, they're only wired up for like one thing. Yeah. If I was in like an office complex, I would have options, but also they would try to like screw me on the price because it's an office. And they know they have like office budgets. Did you see that with, what was it? Boeing was charging like 9 times the price for their soap dispensers to the Department of Defense because they know it's a Department of Defense contract.
And that's always been a thing for like 100 years at this point.
Right? Yeah.
What's the first rule of government spending? Why buy one when you can have two at twice the price?
Yeah, right. Yeah. Average or arithmetic mean, the evil amongst all current economies. Use geometric mean and you'll see the illusion of econ growth, or harmonic mean. Ooh, okay. I need to look these things up. Anyways, so yeah, this is what I did. Recce. I take whatever the middle numbers are from here, I multiply them by this, and then I add them all up. I was gonna start writing them out, but then this was sucking. And then you got to divide by the total number of things. So the cool thing is, instead of me adding up all these, I know that there's 151 data points. So I'm just going to divide this by 151. Yeah, you did the same? Okay, cool. All right. So that gets me an average of 5,115. Cool. So 5115.9. So I assume you can't have 0.9 of a person. So we're going to say 5116. Yeah. Use a table to estimate the median. Bro, this sucks. I don't want to do this. But, okay. We can just estimate that the median is 2,500. And if you want to know why, it's because this data set looks like this. It's like so much here under the 0 to 5,000. So usually you would have to arrange all the data out in a row. And then you would have to go in towards the middle. The nice thing here is that there's such a low number of data points that aren't 0 to 5,000, so the median is gonna be there. So you could just say that the median is 2,500. I would say it's somewhere between there. Yeah, not too bad. What's up, Vendor? Using the actual data, the value for the median population is 1,700. Okay, cool. And the value for the mean is 4,275. How do your estimates compare? They're pretty close. You don't need a z-score table for this. No. No. The only time you need a z-score table is if they want the probability of getting a certain amount of something, and then you need something with like means and standard deviations. This is literally just analyzing raw data. This is what they call actually 5-number summary. Have you ever heard of this before? Called 5-number sum. Which I believe is it min Q1, Q2, Q3, Q4 max? Is that what it is? Is that the 5-number summary? Well, that's actually 6 numbers. That doesn't work out. I think it's min. Okay, here it is. Min Q1, median Q3, max. That's what it is. Yeah. I think that's the 5-number summary. It's just it's a convenient way to describe a data set. Just using 5 numbers, and it'll tell you a lot about what's happening. That's right. Thanks, Math Major. Yeah, and usually they do these. These are called like box plots. I'll show you them. That is what? Ohio Association of Gerontology. Excuse me. What? Box plot. 5-number summary. Yeah, here we go. Yeah, this is what they look like. They're pretty cool. You'll do this a lot in statistics. You'll deal with these. So they'll describe data as if, so the min is like what's the minimum value in your data set, the max is what's the biggest number. The median is kind of an indicator of what's like the overall number that shows up. And then Q1 and Q3 show the quartiles, is what we say. So like the 25th percentile and the 75th percentile. Okay, so it's 0th, Q1, Q2, Q3, and the 100th. Is the 100th Q4? Is that do we call it that? I don't know. Cosmic says, what games do I play? I play the finals these days. I love the finals. It's actually one of my favorite games, Cosmic. Big fan of the finals. But good job, Reki. Yeah, you get a point. Nice. I like the finals. I play Fortnite with the kids sometimes. I haven't done it this year yet. I really need to. And then I also like... I used to like COD. I used to play a ton of Warzone and stuff. And then they murdered my boy, dude. They screwed my game up, dude. Started doing dumb shit like putting unicorn finishers and stuff in the game. And it all became pay to win. I wasn't very happy with it. What do you play, Cosmic? You play anything? Okay. Equity. You want to do some... we're going to do some chemistry, it looks like. Equity, are you still around, Bob? Fortnite and Roblox. I do like Roblox. I'm a big fan of Arsenal. Epic Minigames is really fun. And Doors. I like those two games. Those are really fun. Thanks, Raven, dude. Have a great night, too. Go to bed. I think it's 2 a.m. over there for you. Yeah, Arsenal. Arsenal's sick, dude. Arsenal, I think, is better than COD at this point in view. At this point in time.
Bon chance.
Bon chance. Wait, en chance? What's that?
Bon chance. Good luck.
Oh, bon chance. Bon chance. Or in Spanish, buena suerte. Yeah, good. See you, dude. Okay.
Or in German, viel Glück.
Viel Glück. All right, let's see. This is Equity's question. Looks like chemistry. Calculate the volume in milliliters of 0.324 molar solution of sulfuric acid required to react completely with 2.7. Yeah, practice for your test. Also, I mean, this is chemistry as well. 2.792 grams of sodium carbonate, according to this. Oh, wow. Is this balanced? I think it is. No, it's not. No, it is. Wow. Wow, that's so nice. How does this come out so nice? Yeah, carbon, sulfur, sulfur. That's all right, Demdy boy. Wait, how do you say good luck, Pen Center? What? Okay. It is already balanced. Yeah, thanks, Omega. Yeah. Hey, Kent, dude, this is your stuff. This is chem. Chemistry is like one of my... I say it's my top 3 thing. Top 3 things I like to teach. Until it gets to OChem. And I hate myself. It scares me a lot. Also because you just have to like memorize a bunch of stuff. Like, how does the alkyl group attack the benzo ring or something? What? Okay. So everything's already balanced, which is nice. Which means these things are all 1 to 1 to 1, which is beautiful. I don't have to do any mole ratios. Okay. So, in order for this to react with this, I always like to do... These can all be solved with stoichiometry. You say, question mark, what are you looking for? Question mark, I'm looking for the milliliters of sulfuric acid, so H2SO4, which is equal to, like, what do I start with? Which is 2.792 grams of Na2CO3, okay? Why I think this is super cool is I have what I'm starting with, which is grams of this, and I'm trying to get to mLs of this. So I'm going to have to do a bunch of different conversion factors to, first of all, somehow go from grams to milliliters, but also go from sodium carbonate to sulfuric acid. So the first thing you always want to do is convert to moles. Just in general, you just almost always just need to convert to moles. Just do it. Unless you know exactly what to do. But as a good rule of thumb, if you see a chemistry question and you're having to go from different units, like grams to milliliters, or I don't know, like whatever, PSI to something, whatever, you're probably going to need, and it's 2 different substances, then you're going to need the moles. So I want to convert this to moles, so I need to figure out what 1 mole of Na2CO3 is. And I could look this up with a periodic table, or I could just look this up with Google. Sodium carbonate has a molar mass of 100, or I'm just going to round things, 106 grams per mole. Okay, cool. So 1 mole is 106 grams of this thing. Okay, cool. So now we're at moles of this. That enables me to now convert to a different substance. This is kind of a trivial step, but I'm going to show it anyways, because sometimes things are not one-to-one. But in order to go from Na2CO3 to H2SO4, we have to use what's called the mole ratio between the two, which is just a fancy word for how many moles of this correspond to how many moles of this. If this is like 4-to-1, then this becomes 1 mole of this would be 4 moles of H2SO4. Turns out this is just 1. So I can just say this is 1 mole of H2SO4. So what this has done in my stoichiometry is I have successfully converted from looking at Na2CO3 to now getting H2SO4 eventually. Exactly. It is the connection. Exactly. It is, yeah. People say it's trivial because you're like, oh, bro, you're just multiplying by 1. I'm like, yeah. But this is why, Kent, when I teach this to students, I make them write this. Because if you just start saying like grams, moles, grams, it's like grams and moles of what? You have to keep track of what things are. Yeah. So, yeah. So this is 1-to-1. Cool. And then what we're going to do is then go from moles of H2SO4 to eventually milliliters of H2SO4. Okay. So what I know is this is a 0.324 molar solution, which means, so that means that there's 0.324 moles in 1 liter of this. This is what this is the definition of molar. If something is molar, that's how many moles per liter it is. Okay. So what I can say is that 0.324 moles of H2SO4 is equal to 1 liter of H2SO4. Cool. Because when we were up to here, I had moles of H2SO4, but I know I'm eventually trying to get to milliliters of H2SO4, so I probably want to use this other bit of information to do that. That's going to convert from moles to liters. And then the last step is I wanted milliliters, not liters. So you got to use the conversion for that. So that is going to be that 1 liter is 1,000 milliliters. And at this point, I'm going to leave off the H2SO4 because we already know we're just dealing with H2SO4. Okay, cool. Omega says, I used to do so, and sometimes I still do. That notation is discouraged. Oh, yeah, for pubs? Yeah. Yeah. For publications, they have their own jargon, right, for how they talk about things. I'm curious, what is the accepted form of this? Do you don't put what the materials are? Just it's assumed. Or as my quantum teacher used to always be like, it's fairly obvious that. I'm like, no, bro. No. It's not fairly obvious. It's fairly obvious to you. It's not fairly obvious to me. Anyways, okay. So now with stoichiometry, once we're done here, right? This is also I like doing this. Watch how everything cancels. Look. Grams of Na2. Grams of Na2. Moles of this. Moles of this. Moles of this. Moles of this. Liters of this. Liters of this. What am I left with? Just mLs. And that's what I wanted. Ah, without specifying the substance, only numbers and the unit symbol. Ooh, interesting. Yeah. Okay. I never really read chemistry publications, but I probably could. So, multiply everything on the top, get a number. Multiply everything on the bottom, get a number, divide the two. That gets me that. And then I'm going to divide this by, what is this? 106 times 0.324. Awesome. And that's going to get me 81.29. How many sig figs do I get? I get 3 sig figs. Chemistry loves sig figs. which is just lazy error analysis. But, anyways, I get 81.3 mLs, which I think is what the answer is. Equity. Let me know. Did you get that, or do you have the answer, or do you just had a question about it? Yeah, you're welcome, dude. That's cool. Yeah, I'll send it to you.
Somebody has just reminded me of something. Now all of you must be reminded of it too.
Oh no! What are we being reminded of today? Is it the game, dude? Are you gonna make me lose the game again?
That's that parrot. It's just the voice even. It's just like stuck.
What parrot, dude? What parrot?
First there was one of those weird Gen Z memes where it was just like suck and it was like really distorted and loud. And then there was just the
like this.
And then the parrot one was just suck. Suck.
It's disturbing.
Who teaches a parrot to do that?
Oh, I know the meme you're talking about. Yeah. But I don't think they taught the parrot. I think the parrot was just always in the bedroom at that point.
Yeah, sounds about right.
Sounds about right. Yes. Let me mention equity. You get the point. And then, let me download this for you. Equity. Brings back brings the flashbacks. Yeah, Cosmic, right? Yeah. That's what... I think the reason I enjoy tutoring the most is I feel like I'm staying young because I'm continuing to do questions that were in my childhood. Or college days, I guess. I never left college. Or the children. What are the children?
Remember children. It's 1920 by 1080. Not 1080 by 1920.
Oh, dude. No, dude. No, everything's vertical these days, bro. Did you see Instagram changed? Instagram changed their thing. Let me go to my actual education page. It used to be squares, dude.
It used to be 4-3.
Yeah, now it's 5-4. Oh, this is not actual education. What is mine? Is it actual? Is it underscore education? I need to come after these people, dude. Dude, what? And just be like, can we? Yeah, it's.
That's fine. Have you?
This is 4-3. This is 4-3. I think. I don't think this is square. Right?
That's weird.
Yeah, it changed.
About as square as it was. It was.
Yeah, it changed. We're doing your question right now, Dennis. No, we're doing it right now. Okay, let's see. What classes is this for, Dennis? By the way. Yeah, chemistry labs are terrible, Cosmic. Oh, man. Yeah, what's up, Sam? I do need to chug something. I don't have any cups in here anymore.
Water?
I do need to drink some water. Actually, unfortunately, I don't have any water in here. Can I drink some salt for you? Is that okay, Sam? Just like start drinking salt. What's up, Sam? Okay, this is differential equation. Yeah, I'm sorry, Sam. I'll go. I will fix that for next time. we got the rain though, Sam. Right? Finally got the rain in Los Angeles, dude. Oh my God, we needed this. Sam, what's happening with the Palisades kids? Do you know if your friends are like, or like your younger friends are going to Samo High yet? Or I don't know. No idea. Oh, okay. I don't know if you still had like some friends that were at Pally. Oh, your sister. Oh, okay, yeah, your sister's still in school, yeah. Okay. A 200-kilogram sailboat is floating motionless in the water. Suddenly, a wind with a constant force of 50 newtons begins to push the boat forward. The drag force due to water resistance. Yep. Drag force depends on the velocity. This is why drag force is ugly. Because it's not constant. And acts in opposite direction to the motion of the boat. Let V of t be the velocity of the sailboat after t seconds. Use the fact that mass times acceleration equals net force. Write an appropriate differential equation that determines V of t. This is not too bad. So sum of forces. It's funny how this is in your DiffEQ class. But yeah, I guess it is. So we have the force due to the wind, which is 50 newtons, right? So the sum of the forces is 50. I'm going to call to the right positive and to the left negative. In reality, it doesn't matter which one you call positive or negative, as long as you're consistent with how you label things. So this is 100, and then we're going to subtract 100 V for the force due to drag. Yep. Okay. And then what I know, right, is that sum of forces is also equal to the mass times acceleration. And acceleration is equal to dv dt. Acceleration, we did this earlier actually. This was us helping out Bella. Remember we were doing earlier in the I love this. This is where like questions from earlier students apply to later students. It's fun to see how it's all connected. Yes, I think I wrote it here. Where did I write it? Or maybe I wrote it here. Yes.
It's real estate.
I can't believe it's not butter. But acceleration is the change in velocity of the change in time. Change in velocity over change in time. So I can rewrite this as dv dt. Cool. Do they tell me the mass?
I can't believe it's not butter.
I can't. You know what is it, by the way? Isn't it like hydrogenated soybean oil or something? It's really bad.
I don't know.
Margarine.
What's margarine?
What is margarine? Fake butter? I was born on, what is it, Country Crock? This stuff? I don't even know what this stuff is. Country Crock is a spread made with oils from plants. Okay. So this is what I ate as a child. Was this. Probably terrible for you.
I probably had something similar.
Yeah. Because we couldn't really afford real butter. Like, real butter was expensive. Whoops.
I think my gran had real butter.
Dude, the Irish have the best butter. Dude, I love Kerrygold. Kerrygold's like the best butter ever, dude.
Pretty sure Kerrygold's not butter.
Oh, is it not? Dude, I'm pretty sure it is. Anyways, one sec. We'll talk about butter after this. So M here is 200, okay? So it's 200 dv dt, because 200 is the mass, is equal to 50 minus 100 v. Great. So now you just divide by 200 on all the sides, right? So this comes over here, right? Divide this by 200. So now we have that. Yeah, I think you got it right earlier, Fembox. dv dt 50 over 200, which is a quarter, minus 1/2 v. Correct choice is answer choice A. Nice. That's a fun one.
You on Threads?
Am I on what?
Threads.
Technically, yeah. They kind of forced us. I think if you have Instagram, you kind of got forced on Threads. I don't like it. I don't use it. I think it's just like Twitter again. I fucking hate Twitter. You confuse it. Oh, rate in, rate out. Yeah, this is different. Go away, Olaf. Because this is a yeah. Usually you have like yeah, right. So net change in volume. Say like this would be d volume, dt is equal to the rate in minus the rate out, right? Yeah, that's usually where that comes in. This is physics, though. This is just the sum of the forces, which it kind of is, right? Force in, it's 54. You got 50 newtons coming in, but you got 100 minus v newtons coming out, and then you have to remember that F equals ma. And then they make you remember that A is the derivative of velocity with respect to time. So there's actually a couple physics things in there. Yeah. But I can see how it gets confusing. Okay, cool. All right, I think we got one more question from math. Hey, that's the butter. Math major, you grew up on it too? Wow. Oh, you're going to hit me with like something that's like actually mathy. I would love when these kind of slap. Okay. You might have to help me, math major, because this is slightly above high school math. It starts to hurt my brain. Suppose S is a finite set of points in the plane such that the area of a triangle... Dude, where's Jeff, bro? Jeff, we're talking about triangles and things. I know they're not spheres. They're not your favorite, Jeff, but... He says, I'm out, dude. It's like, what the fuck is this, dude? It's not spherical, dude.
What the fuck is this piece of shit?
It's not spherical, dude. Okay. The area of a triangle is at most 1 whenever A, B, and C are in S. Show that there exists a triangle of area 4 that covers the set S. Okay. Thank you, math. Yeah. First of all, what level? Just so I know what I'm working with. What level of math is this? Is this a discrete math question? Is this a real analysis question? Like what type of math is this? Whenever I see set, I start thinking discrete. Okay. So there's like points, right? So we have A, B, and C, right? Cool. And these all have some coordinate such that the area of the triangle is at most 1. Okay. So area of triangle ABC is less than or equal to 1. So there's a lot of places this could happen, right? Let's say this triangle has an area of 1. I could then translate this triangle anywhere else if I move all the points the same way. And that triangle will also have an area of 1. Okay. Right? Oh, okay, okay. It can be solved with just high school geometry, but it is written for the undergrads that like to compete a little. Yeah, okay, cool. Okay, so it's like a Putnam question. Okay, these are hard then. Show there exists a triangle of area 4 that covers the set S. Oh, I see. And S is a finite set of points? Beautiful. I really like that, Jeff, actually. That's beautiful. Yeah. Jeff has a really good hint here. Yeah. He's saying, okay, first of all, it's a finite set of points, right? So we're going to fix some things. Because if I leave these all unfixed, then there's an infinite set of points that this satisfies. Because I could just translate this whole triangle, you know, wherever I want. But we're going to fix some things. So I'm going to fix A here. I agree with that. Then let's fix B on the x-axis, okay? Okay, S can be all the points containing a parallelogram of area 2. That would be a valid set S, okay. Okay, so if I have a third point here, C, right? Ooh, very cool, actually. And I'm saying that the area is at most 1. Okay. So let's pretend that this base here was equal to 2, right? That means that the height of this, which here I can put like a little dashed line, right? Or here, let's put a solid line. Can be at most 1, right? And then C, I believe, is free to move anywhere along here, right? Isn't that the height is still 1? Like, for instance, like this is a triangle. Wait, sorry, this is a triangle of height 1. Or lower. Exactly. Okay, cool. Yeah, okay. Exactly. Okay, so C has to be somewhere on this line. If I define the distance from A to B to be 2. Okay. So is there a triangle of area 4? Oh, you get a second line below the axis. Thank you. You actually technically do. Okay. Jeff is beating me to the hints of my own problem. Jeff's with the spoilers. Jeff's here only to give me wrong answers, though. Okay. I like this hint. I like this. Is cool. This is a cool question, though. I really like this one, Math Major. This is fun. Okay, so I need to show that there's a triangle of area 4 that covers the set. Okay. So, what if I made my triangle here? Of like height 2? No points can be outside the interval. Right, everything has to be inside here. Right? Okay. Showing us a triangle of area 4 that covers the set S. I'm getting deja vu right now, dude. This is trippy. Okay, yeah. I will ask you in a second here. Let's say this is area 2. Okay. And then what? Am I going to say that this is equal to... I mean, this only needs to be equal to 2 as well. But then this triangle doesn't cover all the points, right? Because it doesn't cover the point over here either, right? Fuck. I need to cover these 2 points, but how do I also cover... Oh, whenever A, B, and C are in S. And S is a finite set of points. This is technically not a finite set of points, right? Isn't this like an infinite set of points? If there's a 4th point, it's limited to where it can be. What does that mean, Jeff? Yeah. Wait, let me read out what you said with the parallelograms are. So, for example, S can be all of the points contained in a parallelogram of the area 2. That would be a valid set of S. Oh. Oh. Okay, wait. S can be all of the points contained in area of 2. That would be a valid set S. Because that's 1/2. Sorry, that's just base times height, right? But how does this... Sorry, math major. How does this also cover these ones? That any triangle containing it has an area of less or 1 or less. Oh, okay. I see. The wording on this one's interesting. Shaded parallelogram of area 2. Yeah. I mean, this kind of looks like a parallelogram, right? This is 2, and then this can be whatever. Math major, give me another hint. Give me another hint. I'm hurting. These are fun. They do challenge my brain. They stretch it out for sure. Let A, B, and C be 3 vertices which make a triangle. 3 vertices which make a triangle the biggest possible area. Okay. Oh. Oh, I like this. Okay, so what if we put this at C, right? And say this was 1. Then Triforce, right? Yeah, okay. Okay. Then this can be anywhere from here, I guess, to here. Is that kind of what we're saying? This is 2. Are we gonna get a Triforce? If I do it right. Let me show the Triforce picture. One second. Talking about this. Yeah, I want to see where this comes from. Yeah, now draw AC and make the dot. Okay, now draw AC. Oh, draw BC. Oh, I see where this is going. Yes, this is... If this is BC... Uh-huh. You should choose one B to be B prime and one... Okay. Okay. I see what you're saying. Okay. Alright, let's call this, like, B prime. Yeah, you want to help him voice? Yeah, hop in voice, dude. That'll help me out, probably. Do you know how to join the... Yeah, come into the stage, and then I'll promote you up. There we go. Nice. Let me invite you to speak. I think you have to hit like accept on it or something. Or you can also like... There he is.
Oh, there we go. Hey, how you doing?
Yeah, what's up, Math Maker?
Hey,
You see, bro.
Excited to be here.
Nice.
Yeah, so this is one of my favorite toy putting in problems.
Okay.
Because you get a really pretty picture at the end. Okay, yeah, so the first step is to just draw any triangle that you'd like. ABC.
Yeah.
That's the biggest possible triangle that you can make in terms of area.
Okay. So I drew this one where I had a base of 2 and a height of 1. And I said, cool, I like this as a triangle. Is that the biggest one?
Sure. Well, I mean, it depends on what parallelogram you start with, right? You could have like a parallelogram that has like a super, super wide base and is really, really short, right?
Yeah.
So the numbers 2 and 1 don't matter.
Okay.
The big insight here is these first 2 parallel lines that you drew, because the triangle is just base height 1/2.
Yes.
You're stuck between like these horizontal lines that you drew.
Right. These ones,
right?
these ones. Yeah.
Yeah, and you're also stuck between these vertical lines that you drew between B and B prime.
Yeah, let me change the colors on these so they're different colors. Yes, okay. Between the red ones and the blue ones. Yes, I agree.
Yeah. Okay, yeah, so now let's draw the line between B and C to finish that starting triangle that you drew.
Okay, so just these ones.
Yeah.
So I want to draw B to C. So yeah, let's do like a pink line between here. Okay. Oh, whoa.
Yeah, that way you actually draw the starting triangle, right? The entire triangle, right? We missed the for that third edge of the triangle, right?
So this is the starting triangle we've drawn. Yeah. Here, let me get rid of these colors too. We don't really need these anymore, right? Okay. Okay, cool. I got a starting triangle. Yeah.
Yeah. Okay, cool. So notice that what you did for the other two lines was, so like the first lines that you drew, you took C and then you reflected it across AB to find the other line. Right?
Okay, cool.
Then for the second line, so you took B and you reflected across AC. So now we're going to do the same thing. We're going to take A and reflect it across the pink line.
Over BC. Ah, okay.
Yeah.
I like. Okay, one second. I see where this is going. Okay, so I'm gonna call this B prime, right? And then now I need to make an A prime that reflects over this. So that's gonna be like somewhere over here, right?
Well, it'll be exactly at the intersection of that.
Oh, sorry, you're right. Oh, you're right. No, you're right. It'll be right here, actually. Okay, cool.
Yeah.
Yes.
Yeah. So now if you draw some parallel pink lines to your starting pink line through A and A prime.
Okay, so like this? Through A and A prime? Or no, sorry. We're talking about this. Ah, I know what you're talking about. One sec. This?
Yeah.
And this. Okay. Yes. Okay, I see. Okay.
Yeah, hold on. Let me give a second for the stream to catch up with what you're telling me.
Oh, can you not see on Discord? Discord, there's a... I should be sharing my screen on Discord, and that has no lag.
Oh, okay. Oh, yeah. Then on Discord, yep, that's exactly right. And so now, okay, so if you shade in your starting triangle with a color, I think this is the easiest way to see it.
Cool. What? Let's just do yellow. Let's do yellow. Shade with
whatever color you'd like.
Okay.
And then shade in all of the triangles that share an edge with your starting triangle. Those are all of the ones that are between all of the parallel lines.
Okay, so like for instance, this one, right? This one. And this one. Yeah. It's a Triforce.
Yeah, it's a Triforce. Right? And if you notice, all of those 3 extra triangles that you built are all just reflections of the starting one. So since your starting
they have
one
that same
had
height,
area
same
less than
base.
1.
Right? Yeah, good. This was less than 1. This is less than 1. This is less than 1. Ah.
Yeah, exactly. So that means that the total triangle that you build overall has area less than 4.
Oh, very cool. Oh, man. Oh, that's dope. Oh, wow. I have to give it that.
That's dope.
Yeah, so like I said, this is just like a super fun problem because like you just have to know how to reflect points across lines. So it's just some geometry stuff.
I would have never come up with this. I would have never come up with this math. Sorry, what?
Oh,
sorry,
no, this one.
What do you want me to call you, by the way? Sorry. What's your what name do you like to be called?
Full name. That's something that you like. It's okay too.
Okay. Cool. Yeah. All right. Nice, dude. This is really fun. I need to do more of these Putnam questions, dude, because there's a fun like the process of this. Learning these skills right here are applicable in like so many other questions.
Yeah, well, I have a giant list of the ones, right? So every year there's like 12 different problems or something like this, and some of them are just absolutely brutal. But some of them like this I actually think are kind of approachable and kind of fun. So
and they teach like
anytime
a concept.
you wanna, so anytime you want an extra fun problem, just let me know and I'll pull one out of the freezer.
Oh hell yeah, dude! No, for sure, dude. Yeah. You know what? The other person that does this in my stream, Shantrix, he does it with. I want to say, is it the Kaylee exam or something? He does it with one of the other exams, but he always picks questions that, yes, are difficult, but aren't like nightmare mode, like insane. You know? So,
yeah,
I appreciate you have a list of like ones that actually teach something useful versus just make you feel like you hate math.
Oh, yeah, well, so I'm a lecturer for a university, and so I run our Putnam problem sessions. So every year when I do the problem sessions, I try to come up with new ones that let the students learn something. So I just have a bunch from like the last 3 years or whatever.
Oh, that's super cool. Yeah, please. Yeah, more than I love that. Yeah, if you see me streaming and like I'm helping the students and whatnot, please, more than welcome to like dump a screenshot in there, or I'll call you out in the chat. And I'll just be like, hey, math major, like. Where's the one I get?
Yeah, and the obvious caveat to that is that if actual students have questions, you should just ignore them.
Well, so this is the thing. Yeah, when Shantrix posts these challenge questions, which was what was the one he posted? It was this one was easy actually, but when he posts the hard ones, I tell him like I'll spend 10 minutes trying to solve it, and if I can't get it send me the solutions, and then I'll go through the solutions. As a way of, like, it doesn't take the whole stream for me just, like, staring, looking dumb, but still gives time for me to help the other students out with stuff. Yeah. It's a balance. Very cool.
All right.
Awesome. Cool. I appreciate that, man, dude. That's super cool. Appreciate the question. Yeah. We learned something today, guys. Cool. Thank you, dude.
And congrats on your lecturer position.
Thank you.
To meet another fellow non-tenure track faculty.
Yeah, the slave labor, but yes, but I'll take it. You know? I know how it works, you know, but it's for the resume at this point. I'm happy.
Yeah. Join the club, man.
Yeah.
All right. Have a good rest of your night, dude.
You too, man, dude. Thanks for coming by, dude. That's super fun. Look at that. See, Sensation, we learned some more math today, dude. From another fellow person who lectures and stuff. Or, let me move you down. There you go. Also, what happened to my music? Why did it just stop? Oh, they just... Oh, there we go. Okay. My lo-fi like killed out for a second. Okay. Thanks, Endar. Yeah. Again, it's not official yet, but when it is, I will make an announcement. I think it's official. We'll figure it out. Okay. I think that's all the questions today. We've been going for almost 3 hours, so let's end the stream, yeah? Cool. All right. Thank you, everyone, for coming to office hours today. Had a really fun time working with all you guys. Your semester starts today? Yeah. This position would be for the winter quarter, which starts in March. So, yeah, UCLA does a quarter system, so they have 4 periods of learning during the year instead of 2. Well, actually, it's 2 semesters, but then there's a summer session, so it's really 3, for semester systems. But yeah, nice. Okay, cool. That was the first stream of the week, which was fun. Thanks everyone for coming. We had a lot of people stop by. We got some donations too and stuff. Love it. We're gonna go raid somebody. Who are we gonna go raid? I wonder. Yeah, I wonder, Sensation, if we've now triggered the feet algorithm. Do you think we're gonna get suggested like feet pages yet? Let's see. Let me pull up my stream manager. Let's go raid. Who does it say we should raid? Okay, some VTuber doing this. Someone having a birthday. Some regular people here. Okay, but who am I following? Who's streaming? There we go. Okay, we got your favorite, Science. He's a nice guy. Whatever. Oh, it's his birthday. I know. His stream is very clean. I get it. I know. Yeah, it's okay. But I guess he's celebrating 2 years as a Twitch partner, and someone's birthday, and he's been streaming for 6 and 7 hours. Dude, look at High Potential, bro. High Potential has been up for 33 hours. He does not stop his streams. Like, I think he's asleep right now. Yeah, he calls it office hours, but he just keeps his stream running 24/7. It's a valiant thing. I don't know if I could live underneath a stream camera all day though. Anyways,
I have seen people do it when it's like special events, and it's like if you sub, I add 30 minutes at the time kind of thing.
Yeah. And the guy gets like $1 million. Exactly. Yeah. Okay, we'll go say hi to Science. I mean, they are pretty cool, and they have been, I guess, streaming for 7 hours. So go say hi to them. All right, awesome. Okay, that being said, our next stream will be tomorrow at 4 p.m. Pacific, 6 p.m. Central, 7 p.m. Eastern. Come on by if you want to go learn some math or science, have fun. Yeah, talk with us. We're gonna have a great time. And with that, enjoy the rest of your Monday. Have a wonderful start of your week. 5 p.m. Mountain Time. Yeah, don't forget Jeff. And thanks, Cosmic. You have a great night, too. And we will see you guys tomorrow. All right. Peace.
And we'll see